Hi people, and welcome to this video. In this video, we'll be working on the Mathematics Paper 2 Preparatory Exam for 2024, and this is from the Gauteng province. Okay, so I couldn't really find the actual question paper. I could only find the answer book, so I hope this works out fine. Remember, as always, this paper is worth 150 marks, and the time allocated is 3 hours. Okay, with that being said, let's get into this video. Question 1 says the table below shows the monthly salaries of 100 employees at Adams Law. So here we have the monthly salaries in 1,000 rands and the number of employees. Okay, and they gave us a cumulative frequency column. So question 1.1 says, draw an ogive, the cumulative frequency graph, to represent the data given in the table. Okay, so in order to draw the cumulative frequency graph, we first need the cumulative frequency. So how we get that is, we're going to take these numbers and we're really just adding them up row by row. So the first number that we have to add in this row is just 3, so we leave that as 3. And then the next number is that 3 plus the 4, which is 7. And then 3 plus 4 plus 13, so we have 7 plus 13, which is 20. And then we'll keep going like this. Okay, so you can just see it as we're adding like this. So it's now 20 plus the 20, which is 40. And then 40 plus 21, which is 61. And then 61 plus 12, which is 73. And then 73 plus 12, which is 85. And then 85 plus 8, which is 93. 93 plus 5, which is 98. And then 98 plus 2, which is 100. Okay, and now that we have our cumulative frequency down, we can plot our ogive. So the money is already here, but there's one thing that we just need to remember with the ogive. So these values are going to go with these numbers in the cumulative frequency. But here's the thing. You need to remember that the number that is over here, that number is, these are x values. This number will always be paired with a y value of 0. Okay, so this is where y is equal to 0. So this will always just be on the x-axis. So in this case, it is 0 as the x value, and then the y value by default is 0. So on our graph, we'll go 0 and 0. And then the next one we have, and then we start counting like this. It's going to be 10 and that cumulative frequency value. So 10 and 3. So we'll go to 10 rand, 10,000 rands, of course, and then 3. So just maybe somewhere about there. Okay. And then we'll keep moving like that. It's going to be 20 and the 7. Okay, 20 and 7, and so on. So 7, this is 5, and then maybe 7 is about here. And then we're just going to plot everything down as we see it here. All of these, they just go and pair with a cumulative frequency value. Okay, so this is what it looks like when we put down the points. And then we're just going to connect the dots. Okay, so we're just going to connect them all through like that. Okay, so like this. And that is our answer for question 1.1. Moving on to the next question. Question 1.2 says, use the ogive to determine the number of employees that received less than 35,000 rand per month. Okay, so we're just going to 35,000 on the x-axis because that's where the money is. And then we're going to check how many employees fall into this category. So we're going to go to 35,000. So that's between 30,000 and 40,000. So from 35,000 at 35,000, we draw a line to the ogive, and immediately we hit the ogive, we go to the left to see how many. So that's exactly about 30 employees. So we can just tell them this is 30 employees. They would be the amount that received less than 35,000 rand. Okay, moving on to the next question. Question 1.3 says, determine the median of the data. So to find the median, you're trying to look for half the data set. So you're just trying to see how much is at half the data set. So we're going to do this by saying Q2. Q2 is the median. So we'll say a half multiplied by, now you always multiply by the frequency, the total frequency. In this case, we know that we have people, right? And there are exactly 100 employees. They say that here, but we can also see it when we summed up the cumulative frequency. So we're going to say a half multiplied by 100. Now that gives us 50. So this is just the position of Q2. It's not really Q2 yet. So it means that we will find the median at the 50th person. So we'll go to the ogive, and in the cumulative frequency, because we said half times 100, the total frequency. So we're going here, I'm going to 50 until we hit the ogive, and you see we hit about there. And when we go down, this is about 45,000. It's in between 40,000 and 50,000 rand. So the median, we can finally conclude that the median is 45,000 rands. And that is our answer. Question 1.4 says, the monthly salaries of the 5 employees in the interval where X is greater than 80,000 but less than or equal to 90,000 are, and so they are putting down these 5 employees' monthly salaries. Now, what they tell us is 2 employees from the interval from 70,000 to 80,000 are promoted and receive monthly salaries of 83,000 and 84,000 respectively. Okay, so they move from this category and they move to this one. So here we have 5 people here, but now these 2 more will be added. And question 1.4.1 says, determine the mean monthly salary in the interval from 80K to 90K. So with these questions, always just check the next question, okay, there, if they ask for standard deviation, so you know whether to put this on the calculator or not. Now, as you can see, they do ask for standard deviation. So let's go ahead and record this data, these 7 values on our calculator. So that's the 5 here and these 2 that have been added to this category now. So on our calculator, we're going to go to mode, and then you need to go for the option stat. Now, the data set we're working with is not a data set with 2 variables in this case, because we're just looking at their earnings. Okay, so these 7 employees. So we're going to go for 1 VAR. Okay, and then let's just put down the values. It's only 7 values. It's 84,000, 85,000, and then 87, 89, that, and then these 2 as well. Okay, and then we'll press AC, Shift, and 1. And then we're going to go for option number 4, which says VAR, so that we can just see the information about the variables. Now, we're looking for the mean, so we'll just go for the mean of those X values. And that is, we'll just put it in decimal form. So this is, the mean is 85,857.14 cents. Okay, so that is the mean, and that is our answer. Now, looking at question 1.4.2, they ask for the standard deviation in this interval. Okay, so the standard deviation of this data set we have recorded, we're going to just say Shift 1. And then to get the standard deviation, remember, just go for option 4 again, VAR, and then standard deviation will be this one. Make sure you don't get the squared, that will be variance, and we're looking for standard deviation instead. Okay, so the standard deviation in decimal form is 2,294 point, and that rounds up to a 3, so 0.63 cents. And that is the standard deviation. Okay, moving on to the next question. Question 1.4.3 says, determine the percentage of employees whose monthly salary lie within 1 standard deviation of the mean. Okay, so again, concerning these 7 employees that we're referring to. So the percentage of employees whose monthly salary lies within 1 standard deviation of the mean. So we will need to find out what within 1 standard deviation of the mean looks like. So within a standard deviation of the mean would be, it's the mean minus the standard deviation, and then the mean plus the standard deviation. And then because it is within, we're going to look for the values that are between these, greater than this, but less than that. So our mean is 85,000. We're just going to put that amount down and subtract it by this. And then, of course, in the second interval, the second coordinates, we're going to just add it. Okay, so it's this 85,000 minus 2,294.63. And then here we'll just say 85,858.14 plus 2,294.63. And we can still do normal calculations on the calculator in this setting. Okay, so minus the standard deviation is 83,562.51. And then we'll change that to a plus to get the other coordinates. So that is 88,151.77. Okay, so this is what we have. And we're just looking for values within these 7 numbers that are greater than this 83K, but less than 88K. So let's see how many values do we have that is within this. Okay, so greater than 83,000. First we have that is greater. This is less, so it's not going to be counted. This is greater, that is greater than it. And then these ones, yes, they're greater, but unfortunately they are also greater than 88,000. So we're not going to include these two. So it's these and then 84,000, okay, because that will also be greater than this number, but less than that. So it's exactly 4. Okay, so the question, all in all, is to find out the percentage. So not just how many employees. So we know that it's exactly 4 employees, but to find out the percentage, we'll have to say 4 over the total employees in this section, okay? There are exactly 7 employees because of the other 2 that were added. So we're going to say over 7, and then this as a percentage, we can just multiply it by 100. Okay, and let's go ahead and see what this gives us. So this is 57.14%. And that is our answer, and that is it for question 1. Question 2 says, during a netball tournament, there are several stalls selling food and refreshments. In a period of 10 minutes, at 6 stalls, the following was observed. Okay, so they list the stall numbers, and we can see that in the first stall, there were 10 customers, and the amount of money spent was 163 Rand, and 7 and 138, and so on. And they have already put the data in a scatter plot. So from the scatter plot, we can see a general increase, okay, in this trend. So this means that more customers at a stall would typically result in more money being spent at that respective stall. Okay, so the first question, 2.1, is to determine the equation of the least squares regression line of the data. So let's take our information from here and let's just put it down and record it. Okay, so we're just going to go from, you can put your calculator back on comp, and then from there go to stat. Then instead of going for 1 VAR, we're going to go for the option that says A plus BX. So that will be the 2 variable data set that we have. And they've already put this down in the scatter plot, so you can see that the X values are the number of customers and the Y values are the amount spent. So let's go ahead and put that down. That's going to be 10 and 163, but you first put down the X values, okay, and then the Y values. Okay, so we can put that in. And then once your data is in, we're going to press AC, Shift, and 1. Now we are looking for the equation of the least squares regression line. Now that equation looks like this. Y equals A plus BX. And so we just have to find the value of A and the value of B. So on your calculator, you're going to go for option 5, which says regression. So I'm going to have to just go here for regression. And then we can see the value of A, B, and even R. So let's go ahead and check out what A is first. So A is equal to 12 point. Now that's going to round up, okay, and then eventually add a 1 to that 5. So 12.6 is what we have there, but we'll just leave it at 2 decimal places. So 60. And then we need to find the value of b. So again, you're going to press Shift 1 and then make sure that you go for regression, and then b is equal to 17 point. That 9 is going to round that 2 up to a 3. So it's going to be 17.33. Okay, so the equation of our least squares regression line is therefore y equals 12.60 plus 17.33x. And that is our answer. Question 2.2 says, predict the amount of money spent by 11 customers. So the customers, that is specifically the x values. So we already got the equation of the least squares regression line, and we can just take that, and in place of x, since x is the customers, we can substitute 11. So this is y equals and all of that, and then times 11, and let's find out what we get here. Okay, and we can see that the amount that would be spent would be about 203 Rand and 23 cents. Okay, so that is our answer. Moving on to the next question. Question 2.3 says, determine the correlation coefficient of the data. So on our calculator, you can just remove all of that. You can just press AC Shift and 1. So Shift 1, and then again go to regression. Then you will see that the third option would be the correlation coefficient R. So we'll just tell them that R is simply equal to 0.9, and that's going to round up to a 5, so 95. And that is our answer, 0.95. Question 2.4 says, the organizers of the event think that there is a very weak positive correlation between the number of customers and the amount of money received at stalls. Motivate whether you agree or not. Okay, so from the correlation, you can see, yes, it's positive, but it's not very weak. It is very strong. So we can tell them no, and then tell them that there is a very strong positive correlation between the number of customers and the amount of money received at the stalls. Okay, so that is it for this question. Question 2.5 says, at another store, 6 customers spent a total of 195. Okay, 195 Rand. If this point is included in the data, will the gradient of the least squares regression line increase or decrease? Motivate your answer without any further calculations. Okay, so we're looking at 6 customers spending this amount. Let's look at what that looks like in our scatter plot. So 195 is around here, right? So just above there. You can see what the data set was doing before. Now, if at another store 6 customers spend an amount that is around here, you see how that does not follow the general trend of this line. If we had to draw the least squares regression line, it may be something like this, right? Now, this point is away from it. If you start adding points that are away from that line, it messes with the consistency that we would have had, the correlation. So with the gradient as well, it's going to decrease that gradient because now you're adding more points here. So this line will not look the same anymore if you redraw it. This line will always follow that general trend, as in where most of the data points are. So because you're adding more points down here, it's going to cause it to decrease. So it's going to cause it to decrease, and it's especially because we're adding a point that is far, or it's not really because it's far, it's because of where it is. We're adding a point that is below that general trend, that line of best fit. Okay, so we'll tell them that it's going to cause the gradient of that line to decrease because we are adding a point that is below that regression line. Okay, so that is our answer. The gradient will decrease, and this is because a point that lies below the regression line has been added. Okay, and that is it for question 2. Question 3 says, in the diagram, P, Q, and R are vertices of triangle PQR. M is the midpoint of QR, and N, which is A and B, is a point on PM in the second quadrant. The equation of line QR is given by 2y minus 3x plus 9 is equal to 0. And we are also told that the angle of inclination of QR is theta. Okay, so the first question, 3.1, says, calculate the coordinates of M, the x-intercept of line PM. Okay, so it is the x-intercept. So at this point, we have the y value of that coordinate being equal to 0. So that's what we're going to do. Now, also just remember that they did tell us that this M was also the midpoint of QR. So we can't just put that so that we know that as well. Okay, so let's go ahead and find M. We're going to take the equation 2y minus 3x plus 9 equals 0. And in place of y, we'll substitute 0. So this is 2 times 0 minus 3x plus 9 is equal to 0. So that just becomes 0. And this is negative 3x. But we can just leave it here and transpose the positive 9. So now we have negative 9. And if you divide both hand sides by negative 3, x is finally equal to positive 3. So the coordinates of M are 3 and 0. And that is our answer. Question 3.2 says, determine the equation of PM in the form of y equals mx plus c. So this line PM, given that we know that M is 3 and 0, we can find the equation of PM. So we would need the gradient first, and then we can substitute 1 point on that graph. So let's write down the coordinates of P and M, and then we're going to find the gradient. So here's the formula for gradient. Okay, and we're going to say y2 minus y1. You can take the second minus the first, or you can just say top minus bottom. So 12 minus 0, and then negative 9 minus 3. So 12 minus 0 is still 12. Negative 9 minus 3 is negative 12. So this, the gradient of PM, is equal to negative 1. And now that we have the gradient, we can find the equation. You can use y equals mx plus c, or you could use this equation. Y minus y1 is equal to the gradient, but we know that's negative 1, multiplied by x minus x1. And then in place of y1 and x1, we're going to substitute a point on PM. Right now, that point, we can go ahead and choose M since it's a simpler point to use. So that's x1 and that is y1. So saying y minus 0 equals negative 1 multiplied by x minus 3. And if we distribute, then y is finally equal to, because y minus 0 is y, and we distribute here, that is negative x and positive 3. So negative x plus 3 is the equation of line PM, and that is our answer. Question 3.3 says, calculate the size of theta. Okay, so theta is the angle of inclination of this line QR. So we have the equation of this line, and in order to find the angle of inclination, we use this formula, tan of your angle of inclination theta is equal to the gradient. So in this case, all we need to find is the gradient of this line. Okay, so since we have the equation, we can find it. So we'll take the equation of that line, and if we rewrite it in its standard form in the form of y equals mx plus c, then we'll be able to see the gradient. So the goal is to get y on its own. Okay, so let's leave 2y on the left is equal to, transpose the negative 3x to become positive, and transpose the positive 9, so it's negative 9. And then we can divide both hand sides of this equation by 2. Therefore, y is equal to 3 over 2x and then minus 9 over 2. So we can see the gradient is 3 over 2. Okay, so to find the angle of inclination, we say tan theta is equal to our gradient, which is 3 over 2. And so we need theta to leave. So we'll use the inverse of tan. So that looks like this, arctan, and that will cancel that out. And we'll have to do that on both hand sides since this is an equation. So theta is equal to, and we can just say shift tan of 3 over 2. And that gives us, so we'll round off to 2 decimal places. So you see that 9 will round up to a 1 there. So it is 56.31 degrees. And that is our answer. Okay, moving on to the next question. Question 3.4 says, show that B equals 3 minus A if P, N, and M are collinear. Okay, so they're collinear, they lie on the same line. So let's look at P, M, and N, and let's see how B can be equal to 3 minus A. Okay, so this is P, M, and N. And we found the equation of this line already in question 3.2, right? We found that that is negative x plus 3. So we'll just keep that in mind. We know the equation of this line, y equals negative x plus 3. But what they're asking us to do is to show them that B, which is the y value of this point, is equal to 3 minus A. So in other words, they're just saying, find the y value of this point. And of course, it was 3 minus A, so it's in terms of A. So take this point as it is. If it is collinear, then it means that it lies on this same line. And the equation of this line is negative x plus 3. So substitute this point, the x and the y value, into this equation so that you can find the y value. And it will be in terms of A. Okay, so we're just going to take n, which is A and B, and substitute it into this equation. Okay, so this is our equation, and we're just substituting the point n, which is A and B. Okay, and so that is the y value is B is equal to, and we'll say negative, and the x value is A, so that's A plus 3. Okay, so as you can see, if you just put the 3 in front of the A, then B equals 3 minus A, because that A is negative. And there we go. Okay, so if it's collinear, it lies on the same line. And so that point lies on that line. So we can substitute it into that equation. Moving on to the next question. Question 3.5 says, hence determine the value of A and B if NQ is 5 square root 5 units. Okay, so this relates to the previous question. You see how they made us express B in terms of A. It was because of this. You would notice that if they give you a length of a line, right? If you knew the length of a line, but you didn't know 2 points on it, meaning you have 2 missing variables, it's not going to be enough to find that A and that B value. But if you express them in terms of the same variable, then you'd be able to find it, because now your equation will only have 1 variable and you can solve for that. So that's the whole point here. So we're going to take NQ, which as we look at it here, NQ is this line, okay? This line over here. And you see it has N and Q. So they told us the length of the line. So we need the coordinates N and Q. But of course, we're going to express N in terms of A. So that's going to be A, and then that 3 minus A. Okay, so let's take our points down. Okay, but B is now going to be expressed like this, 3 minus A, because we were able to express it in terms of A since we had the equation of a line which N lied on. Okay, so that's 3 minus A. And they gave us the length of NQ. So we're going to use the distance formula, the length formula. So NQ is equal to, or the distance of a line, we can just start there, and we put down the distance formula. And we're saying NQ is equal to the square root of, and that's going to be x2 minus x1. But let's try to keep the a's first. So we'll say top minus bottom. So that's a minus 9 all squared plus, and then that's 3 minus a minus 9 all squared. Okay, so this is what we have. And we know the length of NQ. So we're going to substitute in place of NQ. We'll say 5 square root 5 units. Okay, is equal to, let's just simplify this further. So we have the square root of a minus 9 all squared plus, and this is 3 minus 9, which is negative 6. So we have negative 6. So we just say negative a minus 6 all squared. Okay, so at this point, you see that the square root is in the way and it's stopping us from solving for the a that we're trying to solve for. So let's go ahead and square both hand sides of this equation. So when we square that, it breaks open that radical. So here, the 5, you see these two are just being multiplied. So the 5 gets squared, and that's 25. and it's still being multiplied by square root of 5, which gets squared and becomes a 5. So this is equal to, the radical breaks open here, and so what we can just do is distribute here. So a minus 9 all squared, you can square the first term, that gives us a squared, square the last term, that gives us positive 81. First times second term is negative 9a, but you're going to multiply with that by 2, so that is negative 18a. And then over here, square the first term, that gives us positive a squared, square the last term, that gives us positive 36, and then first times second term, that will give us positive 6a, and then times 2, and that gives us positive 12a. Okay, so still in terms of a, and we just need to solve for a. Let's put our like terms together. But first, 25 times 5, that's 125. So we have 125 over there. And then let's just put our like terms together. So that's a squared plus a squared, which is 2a squared. And then negative 18a plus 12. That's like saying 12 minus 18, which gives us negative 6. So negative 6a. And then the constant. So that's 81 plus 36, which 8 plus 3 is 11. So it's already 110, and then 7. So 117. Okay, so that is positive 117. And then we're going to transpose that 125. So we have 2a squared minus 6a. And what's 117 minus 125? That's negative 8. Okay, so notice how all of these terms have a common factor of 2. So we can just divide both hand sides of the equation by 2. So therefore, we have a squared, and then that is negative 3a minus 4 equals 0. And we can factorize now. So we know that a times a gives us a squared, and then we need factors of 4 that can give us a 3. So we can try 4 and 1, but you see that this is negative. So 1 needs to be negative, 1 needs to be positive, but you need to ensure that the middle stays negative 3. So give the negative to the bigger factor and give the positive there, because negative 4 plus 1 is negative 3. Okay, so that's minus 4, positive 1. And so a is either equal to positive 4 or a is equal to negative 1. Now, they told us something about a and the quadrant that it is in, or that point really. They said that this point is in the second quadrant, and we can see that. So do you see that this is going to be a negative x value, okay? It goes behind to the left of the 0. Okay, so I just made more space. So it means that, and I realized that I said x, this is a. Okay, so this means that a is negative 1. And if a is negative 1, this means that b, you can see that that y value is 3 minus a. So b would be equal to 3 minus negative 1, which is positive 4. So there we go. That is what a and b are going to be. A is negative 1 and b is positive 4. And that is our answer. Question 3.6 says, determine the equation of a circle having a center at O, the origin, and passing through point R. Okay, so this circle center is at O, this origin, and it passes through R. Okay, so something like that. We don't really need the diagram. But if this is the center and this is a point on the circumference, then all we need to find is R. We already know the center is 0 and 0. So R, how do we find R? Well, now looking at it like this, do you remember what they told us about this line QR? They said that M was the midpoint of this line. So we can find R using the fact that this is the midpoint. So using the midpoint formula, we are going to see these as our endpoints, Q and R, because those are our endpoints. We're trying to find the midpoints, but we already have it. So let's take Q and R, and that will be our X1 and our X2, because this doesn't have any points. You'll call it X and Y. So that's your X2, and then that's your Y1 and Y2. In any order, really, it's fine. Okay, and then that's the actual midpoint. So let's just get our points down. Okay, so using the midpoint, it's X1 plus X2, and just put down our formula. Okay, and we're going to say the midpoint. To find the midpoint, we'll substitute these values. That is X plus 9, so I'll just go in this order, bottom and top. So X plus 9 over 2, add y plus 9 over 2. But the thing is, we already have the midpoint of this line, RQ, that we're finding. Okay, so that midpoint is 3 and 0. So this is the actual midpoint of RQ, and this is the calculation for the midpoint of RQ. So they're the same thing, they are equal. Okay, so since they're equal, we're going to equate their x values. So 3 equals x plus 9 over 2. Therefore, you can just cross multiply. So that's that invisible denominator of 1. X plus 9 is equal to 6. And then transpose the 9. So 6 minus 9 is negative 3. So we found the x value. And now here, we'll say the y value, which is 0, is equal to this y value, which is y plus 9 over 2. Again, we can cross multiply, or you can just see this as multiplying both hand sides by 2. And so we'll have the y plus 9 equals, and 2 times 0 is 0. So y is equal to negative 9. And there we go. That is the point R. Now that we have the point R, we can find the equation of this circle. So R is negative 3 and negative 9. So they told us that this circle has a center at the origin, okay? And it passes through R. So the equation of a circle is x minus a all squared plus y minus b all squared is equal to r squared. But in this case, the origin is the center. So since the origin is the center, you don't have to write it like this. We can simply just say, because the center is a and b, since it's just going to be 0 and 0, x minus 0 is x, y minus 0 is y. So this can just be written as x squared plus y squared equals r squared. So this equation is almost complete. All we need is that radius. Okay, you can choose to find r squared however you want, whether you want to use the distance formula from the center of the circle, the origin, to r, or you just want to substitute it here. It's easier to do it like this. So this is our x and that's our y value, and we'll substitute it into this equation. So negative 3 all squared plus negative 9 all squared is equal to r squared. So 3 squared is 9 plus negative 9 squared, or 9 squared, is 81. So you see that that gives us 90. So we can just say 90 equals r squared. So therefore, the equation of this circle is simply x squared plus y squared is equal to 90. And that is our answer. Question 3.7 says, the acute angle between lines QR and the line with the equation y equals mx plus 4 is 45 degrees. Determine the possible values of m. Okay, so the possible value or values of m. So the main goal is to find this gradient. And this gradient belongs to a line with this equation. And what we did with that gradient is, of course, we would find the angle of inclination. And with that angle of inclination, whatever the angle of inclination of that gradient gives us, we took that, and with the angle of inclination of QR, we subtracted them, and they give us 45 degrees. So I'm going to put down a diagram just so that we can think this through. Okay, so the main goal is, in order to find what they're asking us to do, they are specifically saying that the angle of inclination of QR, right? We take that angle, and now I can't just say we subtracted by this. We would have to consider two possibilities. So we take the angle of inclination of line QR, we take the angle of inclination of this line, which we're clearly going to have to call it something. Let's go ahead and just name that. I'll call it alpha. So the angle of inclination of line this, I'll call that alpha. Okay, of course, that is the angle of inclination that it creates with the x-axis. So what is going on is we're trying to find that gradient. And in order to find that gradient, we need this angle of inclination. So now the goal is to find the angle of inclination of this line. Okay, so to find that, they told us that they took the angle of inclination of QR and they subtracted it by the angle of inclination of this line. Now, I can't just say it's like this because here's a visual on this. So look at what is going on. We have, now I'm sure we could use this diagram, but I don't want to complicate things. So let's actually just look at it on a very small scale. So we're going to have the line QR, which we already know what it looks like. QR is this line over here. It's an increasing function. Okay, so we have QR and it has a y-intercept. Let's just remember, what was that y-intercept? We definitely have it because we found the equation of it at some point because we needed the gradient. Okay, so the y-intercept is -9/2. And let's just put that down over there. So if this is at -9/2, so this is line QR, then this line with the equation mx plus 4, here are the ways that it could look. It could be a situation where we're actually saying that the angle of inclination of QR minus alpha gives us 45 degrees. And so for you to have done that, then this line QR would have to be above the line with the angle of inclination alpha. So it will look something like, maybe like that. Okay. Now, the reason I'm considering this is because remember that these are not drawn to scale. So this thing that even looks like the x-axis, let's just say it's not the x-axis, because if I had to say it is the x-axis, then I'm already assuming that they intersect at the x-axis, and they never told us that. So I'll leave it as a dotted line. I'm not implying it's the x-axis. But the angle of inclination, when we find the angle of inclination of this line, QR, then we will take that entire angle and subtract it by the angle of inclination of this line. Okay, I might as well change that to red since that's what we're calling alpha. Okay, so this is the first situation we can consider. This angle minus alpha, like that. Okay, so that is that line y equals mx plus 4. Now, the second situation we can consider would look like this. Let me just move this over. Here is the second case scenario. So the second case could be that alpha, to find that 45 degrees, we actually said alpha minus the angle of inclination of QR. And then that gave us 45 degrees. Now, in this situation, because it gave you a positive number, this will imply that this line, right, that line is actually above this line QR. So it would look like this. We could still have QR the same way it is. Okay, and then this line y equals mx plus 4 would lie above it. Okay, now before drawing that line down, let's just also take note that this has a y-intercept of 4. Okay, and we know that this y-intercept is -9/2. So if the y-intercept was 4, it would still work out there, given that this is not necessarily the x-axis. We're not implying that they intersect at the x-axis. Okay, so in this situation, what that line would be, or what it could also be, is instead of a line that is increasing, it could be a line that is decreasing. So this one has an acute angle. This one could have an obtuse angle. So it could look like this instead. Okay, so these are two possibilities that we're going to have to take into account. So this could just look like that. And again, the diagram is not drawn to scale. So in this case, here the y-intercept would still be 4, and here the y-intercept would still be -9/2. So we have to consider the both cases. In this case, alpha could be acute, and in this case, alpha could be obtuse. Okay, so let's look at how we can get to this. Okay, so remember, we can have an angle minus alpha and then it gives us 45 degrees, but alpha is still acute as long as it is less than whatever that angle is. And that brings us to our next step. We need to find out exactly what this angle is, because the whole point is you're going to take this angle minus alpha and it gives you 45 degrees. Well, we have the value of this angle, so it means that we can find out what alpha is immediately. Okay, so let's try and find alpha by finding that angle. We already had it. They asked us to find the angle of inclination at some point, and that was 56.31 degrees. So let's use that angle. Okay, so the two cases of alpha, what alpha could be is, if this is 56, let's just do the calculation over here. So we're saying that 56.31 degrees minus alpha is equal to, and let's just find that acute first so we can find that reference and see whether it should be obtuse or acute. Okay, so this is equal to 45 degrees. this is what they told us, okay? The difference between their angles of inclination is 45 degrees. So with this, alpha would simply be just transpose alpha. So you'll be saying alpha equals 56.31 minus 45, okay? So let's find out what that is. Okay, so that would simply just be 11.31 degrees. Okay, so this is what alpha could be. But remember, we're considering two cases. Alpha could be acute or it could be obtuse. So if it was acute, it would be 11.31 degrees. If it was obtuse, it would be this acute plus 90 degrees because it needs to be obtuse, meaning it needs to reach the second quadrant. Okay, so from here, we would simply add 90 degrees. Okay, and so this could be alpha, or alpha could also be plus 90 degrees, which will be 101.31 degrees. Okay, so these are the two possibilities of alpha. Okay, alpha could have been acute as well. 101.31 degrees minus that 56.31 would give us that difference of 45 degrees. Now that we know what alpha could be, the two possibilities, we can actually find that gradient. That was the whole point. We need to determine the possible values of m. So we know the angle of inclination of that line. So we can use the formula to find this, which is that tan theta, or in this case alpha, is equal to our gradient. So we're simply just going to say we'll find the gradient by saying tan, and the first angle we'll try is 11.31 degrees. Or it could also be that the gradient is equal to tan of this angle, 101.31 degrees. And let's just find out what those gradients could be. So the first one was saying tan 11.31 degrees. And that gives us 0.2000. So this is 0.2, okay? And 0.2, that's really just 2 over 10, and that's 1 over 5. Okay, so you can just check 0.2 as the fraction is 1 over 5. So that's 1 over 5. That's the first gradient it could be. The second, we would just have to change that to 101. So tan 101.31 degrees. And that, therefore, tan equals negative 4.999. That is just going to round up to 5. So negative 5. And that is what the gradient could be. It could be 1 over 5 or negative 5. And that is our answer. Question 4 says, in the diagram, the equation of the circle centered at B is given by the equation x plus 1 all squared plus y minus 1 all squared is equal to 20. And then they tell us that DF is a tangent to the circle at A with D and F, the x and y intercepts respectively. C is negative 1 and 6, so we should probably put that down. This is negative 1 and 6. And this is a point on DF with BC parallel to the y-axis. So if this line is parallel to the y-axis, it's simply just a vertical line. Okay, so that should tell us something about this point. And then they tell us that this angle CBA, this angle over here, that it is equal to the angle ADO, this angle, and they're both equal to theta. Okay, so the first question is to write down the coordinates of B. Okay, so we don't really have to overthink this part. They give us the equation, and they told us that B is the center of the circle. So this is in the standard form of the equation of a circle, which is x minus a all squared plus y minus b all squared is equal to r squared. So this means that to put this as x minus a value, you're going to have to rewrite it as x minus negative 1 all squared. And then this is still y minus 1 all squared. Okay, so we can see now that a is actually negative 1 and b is 1, y minus b. Okay, so there we go. It's negative 1 and 1. And those are our coordinates of b. So we can tell them that b is negative 1 and 1. And that is our answer. Question 4.2 says, show that AC equals the square root of 5. Okay, so we have to find this length, AC. So how do we find the length given what we have? Remember that this is the center of the circle. So from the center to the circumference is the radius. And this line, DF, is a tangent. So the radius and the tangent are always perpendicular at their point of contact. So we have a right angle triangle. And in this right angle triangle, we have these 2 points. You don't even have to use the distance formula for this part because this is a vertical line. So it means that C, right, the y value is 6 and B's y value is 1. So the difference will tell you the length of this line, BC. So BC is 6 minus 1, which is 5. So we can just tell them that first. Tell them that we know what BC is. BC is 6 minus 1, 5. And now that we have BC, to find AC, we can just use Pythagoras. So we would need AB. So how do we find AB? Well, AB is the radius. So if you have the equation of the circle, you can find the radius. You see how the radius, right, over here, this is actually r squared. So to find that, you can say the square root of 20. But that is unnecessary. Here's the thing. We're going to use Pythagoras to find this. So we will say AC squared equals, and we're going to take the longest side squared, the hypotenuse, so that's BC squared minus AB squared. See how they're all being squared? So we just need their squared value. Okay, so AC squared equals BC squared minus AB squared. So we'll say AC squared is finally equal to BC is 5, so that's 5 squared. And we know that AB squared, the radius squared, so that is the radius. And we can see r squared is 20. So that is already 20. Okay, we don't have to square that. So that is 20. And now we can finally find AC. So if you square root both hand sides, we will find AC. Therefore, AC is equal to, that's 25 minus 20, which is 5. And that is the square root of 5. And that is our answer. Question 4.3 says, write down the value of tan theta. So to find tan theta, we're related it in reference to theta over here. So we found all of these sides. We know that the hypotenuse is 5, that this side over here is the square root of 5, and we know that this would be r squared is 20, so the square root of 20 to find the radius, okay, not r squared, but r. That would just be the square root of 20, which is 2 square root 5. So 2 root 5. That's what we have there. Okay, so tan is speaking about toa, using SOHCAHTOA. So that is the opposite over the adjacent in reference to theta. So the opposite side is AC and the adjacent side is AB. So that's what we're going to say. Tan theta equals AC over AB. So tan theta equals AC over AB. Therefore, tan theta is simply equal to AC was the square root of 5 and AB was 2 square root 5. So you see how the square root 5 cancels, and that is just 1 over 2. And that is our answer. Okay, moving on to the next question. Question 4.4 says, show that the equation of AB is given by y equals negative 2x minus 1. So they want us to find the equation of AB. Notice how we have lengths all through, but we don't really have that coordinate A. So in this case, here is what we're going to do. We can still use the relationship between the radius and the tangent, but we actually have more information on the tangent. Okay, so here, you know how the previous question usually helps you with the next question? This is one of those cases. In the previous question, we found the value of tan theta. Now remember that they told us that these two angles are equal, right? So this is theta over here, and that is theta. If the value of tan theta here, right, since theta is the exact same thing, tan theta was equal to 1 over 2. That's also going to be the same over here. Since this is theta, then if we just drew a line down, a construction line, okay, then the ratio here, because we're saying something over another thing, it simplifies to a ratio. The ratio here of tan theta would also be 1 over 2. Okay, so opposite, whatever that opposite side is, regardless of how you extend it, whether you put it all the way here, all the way here, okay, that opposite over the adjacent is still going to be 1 over 2. Now, here's the thing with gradient. Okay, so because to find the equation of line AB, we need the gradient of this line, since we don't know what A is, so we can't really find that gradient. So to find the gradient of this line, here's the thing. Remember how tan theta is equal to the gradient? It's because of what the gradient calculates. The gradient says y2 minus y1 over x2 minus x1. So if you had a point and this was x2 and y2, and that was x1 and y1, then finding the gradient here, we would say y2 minus y1 over x2 minus x1. But to find theta, we say the opposite side over the adjacent side. Okay, so that is the reason why tan theta is equal to the gradient. Okay, these are ratios. They'll give you the exact same thing. Okay, so that's the reason why that is the equation to find the angle of inclination, because it helps to find that angle that was created by that line, okay, intersecting with the x-axis. Okay, so removing all of this, we're just saying now we know that tan theta is equal to m. Okay, so with these questions, it seems like they're really just trying to test your understanding of geometry in general. So here's the thing. We know what tan theta is for this. It's 1 over 2. So your gradient will also simplify to 1 over 2. So it means that the gradient of DC is actually 1 over 2. Okay, so we're just going to have to tell them all of this. So I will start by saying, well, tan theta is equal to a half. So this means that the gradient of DC is actually a half. And now that we know the gradient of DC, to find the equation of AB, to find that gradient, we can find that by saying this is the line DC, and we know that DC is perpendicular to AB at this point A. So we're going to say the gradient of that tangent multiplied by the gradient of this radius will give us -1. So we're using that property of the gradients of perpendicular lines. So because of that, it means that the gradient of AB, you can use that gradient 1 times gradient 2 equals -1 and then find it like that. Or you could just do this. You're going to switch the numerator and denominator. So that's 2 over 1, which is 2. And then you multiply that by -1. So it means that the gradient of AB is -2, just like they have it. And now all we have to do is find the equation. So to find the equation of AB, you need a point on AB. Do we have a point on AB? Yes, we have the point B, -1 and 1. So we'll substitute that into our equation. So you can use y equals mx plus c, or you could use this, y minus y1 equals, the gradient is -2 times x minus x1. And then in place of x1 and x2, we substitute that center B, which is -1 and 1. So y minus 1 equals -2 times x minus -1, which becomes a +1, and then simplify. So we can distribute here. That's -2x, and that's -2. And when you transpose this -1, it becomes +1. So y is equal to -2x. -2 plus 1 is -1. And there we go. That is the same equation they have. And that is the answer. Question 4.5 says, determine the coordinates of A. So we have to find those coordinates of A. So A is over here. Okay, so it's that intersection between the line DC and the line AB. Okay, so since it's the intersection, we can just find the equation of line DC, and we already have the equation of line AB. We just found that, and then we can use that and equate them so that we can find their point of intersection A. Okay, so the first step is let's go ahead and find the equation of line DC. Now, we already have the gradient. Depending on which method you used, you would already have the gradient, or you could easily find it because they are perpendicular. If this gradient is -2, then this gradient is a half, okay? Okay, so technically, because of the previous question, we already have the gradient of DC. And so we can just tell them that we know the gradient of DC, and we'll just substitute a point on D. So the gradient of DC is a half. And then to find the equation, we substitute 1 point. The point on DC that we have is C, which is -1 and 6. So let's go ahead and substitute C as -1 and 6. So you can either use y equals mx plus c or use this equation. So I'll say y minus y1, and y1 is 6, is equal to 1 over 2, and then multiplied by x minus x1. So that is minus -1, which becomes a plus 1, and this is equal to, so we'll say a half x, and then plus a half. Okay, what is a half? And then that comes over and becomes plus 6. A half plus 6 is, you can just multiply the denominators. That is 12 plus 1, 13. So that's 13 over 2 plus 13 over 2. That is the equation of DC. Then, to find their point of intersection, we're going to equate the equation of DC with the equation of AB. So this is, the equation of AB is -2x minus 1. So we're saying -2x minus 1 is equal to a half x plus 13 over 2. And then if you transpose -2 plus a half is 5 over 2. So that's 5 over 2x is equal to, and here we just have -1, and that goes over and becomes a minus 13 over 2. You can see this as -2 over 2. That is still -1. And so they become -15 over 2. That's minus 15 over 2. And then to solve for x, you can divide both hand sides by 5 over 2 or multiply both hand sides by 2 over 5. So when we do that, x is finally equal to, here, 2 and 2 cancels and they're gone. And what is -15 divided by 5? That is -3. Okay, so now that we have solved for x, we can just take that and substitute it into either equation, since the x and y values are exactly the same on those two lines. So y equals -2 times -3 minus 1. I'm substituting into equation of AB. So y equals, and that's going to be +6 minus 1, which is 5. So there we go. The coordinates of A are -3 and +5, and that is our answer. Question 4.6 says, calculate the ratio of area of triangle ABC to the area of triangle ODF, and simplify your answer. Okay, so they want us to find what the area of triangle ABC is to the area of triangle ODF. So we can just find these areas over each other so that they become a ratio. They simplify to a simplified ratio. So this is going to be the area of triangle ABC over the area of triangle ODF. Okay, so this is what we're going to have. And let's just go ahead and find this first, looking at ABC and ODF and what we can see there. Okay, so with ABC, you see that we have everything we need here to find the area of a triangle, and these are right angle triangles, so they're helpful here. So to find the area of that triangle, you just need to say a half multiplied by its base, multiplied by its perpendicular height. And in this case, we have a base of the square root of 5 and a perpendicular height. Okay, it's perpendicular to the base of 2 square root 5. Okay, so that one is done. ABC is fine. And then ODF. So if it is this triangle over here, right, this is also a right angle triangle because the x-axis and the y-axis are perpendicular. Okay, so that triangle over there. Now, with this, we would have to be able to find the area of this blue triangle, we need the base and we need the height. So we need to find out exactly what that base is, meaning we just need to find the point D, which is just the x-intercept of this line DC. And we have the equation of DC now. So we can find that. That's the x-intercept. And then we need the height. So to know how high this goes, we need to find out exactly what F is. Okay, so that's all. And that's the y-intercept. We also, again, have the equation of line DC. So we're just going to take the equation of line DC, which is this equation over here, and we're just going to find its x and y-intercept. So the y-intercept is clear, and the x-intercept, we're just going to have to work on that. Okay, so To find the x-intercept, we make y equal to 0. So 0 equals a half x plus 13 over 2. Okay, so the denominators are 2. It's kind of like just multiplying both hand sides of this equation by 2. And so we're just going to have 0 equals, that is going to be x, okay, because the 2 cancels and we have 1x, and then plus 13. And if you transpose 13, x is equal to negative 13. So that is D, that's the x-intercept, negative 13 and 0. Okay, so it would mean that that length, okay, of O till D is, OD is 13 units. We know that now. And then to find the y-intercept, here it is, okay? It's y equals mx plus c. C is that y-intercept. So we also know what the y-intercept is. So we can say the y-intercept will be found by just seeing that over there. That is f. And so that as a coordinate is 0 and 13 over 2, which is 6.5. Okay, so it means that from O to F, right? This is actually 6.5 units. That is 6.5. So it is there. So here we said OD is this, and here we're saying OF is 13 over 2. And now we can find their areas. Okay, so following this still, we're saying the area of triangle ABC over the area of triangle ODF. To find the area of triangle ABC, we'll say a half multiplied by its base. And we know that the base of triangle ABC, let's just capture that base and height quick. Okay, so the base is square root of 5. The height is 2 square root 5. Okay, a half times the base times the height. So times square root 5 times 2 root 5. And this goes over a half multiplied by the base here was OD, which is 13. And then times 13 over 2 as the perpendicular height. Okay, so we just have to simplify this. You see that a half would cancel, and you can just use a calculator at this point, it's fine. And that is equal to 20 over 169. And there we go, we found that. So just to answer them, they said we need to calculate the ratio of the area of triangle ABC to the area of ODF. So we're going to put it in that form. We can see that simplified to 20 and that simplified to 169. Regardless, they would just simplify together. So the ratio is 20 is to 169, and that is our answer. Question 5.1 says we need to simplify this trigonometric expression to a single trigonometric term. Okay, so the entire expression is this, including the 1. So let's start. We first have a sine squared 180 degrees plus x. Now, from our reductions, we know that 180 degrees plus x, that this lies in, we can say plus theta, that's fine, plus x is still okay. So that lies in tan's quadrant. And we know that sine is negative in this quadrant. So what happens with that is we will have a negative sine x, but then it is squared. This is sine squared 180 degrees plus x. So that gets squared. And when it gets squared, it's really just going to become positive sine squared x. So regardless, it stays positive. And then it is multiplied by sine negative x. Notice that the angle here is negative. So we can simply just add 360 degrees to this. So this is sine 360 degrees minus x. And now we can reduce it. So looking at that, 360 degrees minus x lies in cos's quadrant where sine is negative. So this reduces to negative sine x. Okay, it's multiplied by negative sine x. And then we'll put this all over. And here we have a negative and then sine 90 degrees plus x. Using our cofunctions, sine 90 degrees plus x is equal to cos x. So we just have negative cos x, that negative stays. And then it's multiplied by tan x. Whenever you see tan, okay, and you see that we have causes and sines, you might as well just change it to its identity. So this is sine x over cos x. Okay, and now this is equal to, looking at the numerator, we have a sine squared x and a sine x, negative sine x. there's no use of multiplying them together because you see that in the denominator, they're going to cancel with things there. So let's start with the denominator. Here we have a negative cos x and a denominator of cos x. Now this has a natural denominator of 1. So since they're multiplying, if you have common factors diagonally, they will cancel. So cos x cancels with cos x. We still have that negative over there. And then in the numerator, you will notice that this negative sine x will cancel with this sine x. Of course, that's also negative. So a negative divided by a negative is a positive. Okay, and then we have minus 1. Let's just keep that in mind. Is equal to, and here, what will happen is the cos x and this cos x, okay, we know there's a negative here, but this will cancel with this because this is in the numerator, okay, in this denominator. That's in the numerator and the 1 is in the denominator. So they cancel across because they are common. And now in the numerator, look at what happens. This negative sine x is going to cancel with, of course, the negative, and the negative will divide and become positive. But the sine x is going to cancel with this sine x because what will be left, and we can't just do that. Let's just write another line. What will be left is sine squared x multiplied by sine x over, and now all that is left in the denominator is sine x, and then we have minus 1. So this is simply equal to, this is now sine x and sine x cancel, and we have sine squared x minus 1. Okay, so remember that they want us to simplify this to a single trigonometric term. So we have an identity that includes sine squared x and 1. This is this identity. Okay, and if we make sine squared x the subject so that we can introduce a 1 that will cancel with this 1 over here, what will happen is you have sine squared x is equal to 1 minus cos squared x. Okay, so we're going to, in place of sine squared x, say 1 minus cos squared x. And then we still have the minus 1. And then you see that the 1 and the negative 1 cancel. And all that we are left with is negative cos squared x. And that is our answer. This trigonometric expression simplifies to negative cos squared x. Question 5.2 says, given cos a minus b equals cos a cos b plus sine a sine b, we need to use the above identity to deduce that sine a plus b is equal to sine a cos b plus cos a sine b. This is a question that shows up a lot. So we are using the idea here, and we're really just using it to derive a formula for sine a plus b. So here's how we can look at this. This rule says cos of a first angle minus, and it's specifically minus, a second angle is equal to cos of that first angle, cos of the second angle, and then the sign should change to a plus, and then sine of the first angle and sine of the second angle, okay, and then multiply. So how do we use this idea to expand this so that it can look like that? Okay, the first problem is we're looking at this and just trying to find out how we can use this idea over here to make this look like that. Well, the first problem is this is cos and that is sine. So since we're working with this, because we're just using this idea, working with sine A plus B, we need to make sure that this says cos instead of sine. And we can do that using cofunctions. So we're going to change this to cos 90 degrees minus, and this is going to serve as our reference angle. So this is A plus B. This follows the same idea that sine theta is equal to cos 90 degrees minus theta. Okay, great. So now it says cos, and we'll be able to expand this if we have cos and then a first angle minus a second angle. So here's the thing with that. We have 90 degrees and then we have A plus B. A plus B cannot serve as our second angle right now because if not, we will not be able to simplify it further. So what we're going to do is distribute this negative into the A and the B. So this is now cos, and we have 90 degrees minus A and then minus B. And now that it's like this, we can just group 90 degrees and minus A together, because 90 degrees minus A is going to create a cofunction, and then that will be able to simplify to a single trig term. Okay, that is why it's not ideal to group these two together. So now that we have that, it's going to follow the same idea. See how we have cos of a first angle minus a second angle. Well, we have the same idea over here. Cos of this now serves as our first angle, and then we have minus a second angle. So we're going to use this rule on this. So we're going to say that this is equal to, you see how this expanded to cos of that first angle. So we will also say this expands to cos of our first angle, which is 90 degrees minus A, and then multiply by cos of the second angle. And here, their second angle is B, and our second angle is also B. Then, because they had a minus, we also have a minus in the middle, it changes to a plus, so this is plus. And then sine of the first angle, okay, and we're going to say sine of our first angle, which is 90 degrees minus A, and then sine of the second angle, and our second angle is also B, like they also have it here. Okay, and now that we have expanded it to this, we can finally simplify this further. So this is equal to cos 90 degrees minus A is a cofunction, and we know that that simplifies to sine A. And then we have times cos B, and then we have plus sine 90 degrees minus A. That's also a cofunction, which simplifies to cos A, and then we have sine B. And there we go. We have created the identity for sine A plus B using the rules of cos A minus B. Question 5.2.2 says, without using a calculator, simplify the following. So we have cos 420 degrees and cos 15. We can go ahead and start reducing these. So 420 degrees is an angle that is greater than 360 degrees. Whenever we see angles like this, we simply subtract 360 degrees from it. Okay, so if it's greater than 360, minus 360. If it is negative, add 360. And we get 60 degrees, which is great. That is a special angle. So we have cos 60 degrees and then cos 15 degrees, and we can work with that. Cos 15 degrees and then 300 degrees. Now looking in the cos diagram, 300 degrees is an angle greater than 270 degrees but less than 360 degrees. So it lies in the fourth quadrant, in cos's quadrant. So it will use this reduction 360 degrees minus theta. So that is plus sine, and we're going to say 360 degrees minus what gives us 300. You might as well just say 360 minus 300, which is 60, right? And when we reduce this, because it is in cos's quadrant, sine is negative in that quadrant. So it reduces to negative sine of 60 degrees. Okay, and then we have 105. 105 degrees can also be reduced. It is greater than 90 degrees, but less than 180 degrees. So it's in sine's quadrant. Okay, cos is negative in sine's quadrant. So when reducing this, we'll say this is cos 180 degrees minus what gives us 105. That's minus 75 degrees. And so if you reduce this, this is equal to negative cos 75 degrees. Now, if we look at the angles that we have, notice that they're actually following a pattern. We've got 60, 15, and then we've got 60 and then 75. So that can be changed. Now you'll notice that because these two are the same, these two could also be the same. Okay, their angles could also be the same. But this is 15 and that's 75. And what do you notice about 15 and 75? They're complementary angles, so they'll add up to 90 degrees, meaning we can use cofunctions here. So let's just follow a rule. Since this says cos, and then this can say sine and sine, so we'll change this one to sine using cofunctions. Okay, so what we have now is cos 60 degrees, cos 15 degrees, and then minus sine 60 degrees and multiply by, now this is still negative. When they multiply, they'll become positive. So we might as well just make this positive because it's negative multiplied by a negative, which is positive. So now we're going to look at that as cos 75 degrees. How do we change this to its cofunction? So we can change it to sine 15 degrees. And now that it looks like this, it's following the compound angle rule for cos. So we're going to make this simplify to, remember, it's following this rule. Okay, so it simplifies to cos 60 degrees minus 15 degrees. Okay, so what's 60 minus 15? Oh, that is 45 degrees. So this is cos 45 degrees. Now notice they say without using a calculator. 45 degrees is one of those ones that if you use a calculator, they will know. So here's what we can just do. We can use a special angle rule called the OHA rule. So the OHA rule works like this. We say OHA, O-H-A, which is opposite, hypotenuse, adjacent. And then we say 30 degrees, 60 degrees, and 45 degrees. Then we say 1, 2, 3, 3, 2, 1, and 1, 2, 1. And then in each row, square root the biggest number. So we'll square root the 3 here, square root the 3 here, and square root the 2 here. So when we're looking for cos 45 degrees, follow what SOHCAHTOA says. With SOHCAHTOA, we know that cos is equal to adjacent over hypotenuse. So we'll go to the 45 degree row and we'll take the adjacent over the hypotenuse. So that is 1 over root 2. Okay, so cos 45 degrees is simply equal to 1 over root 2. And that is our answer without using a calculator. Question 5.3 says, given tan squared x multiplied by 1 over tan squared x minus 1, we need to prove that the left-hand side is equal to the right-hand side. Okay, so go in with the left-hand side since we have things to simplify. So we can simplify this by expanding this using tan's identity, which is sine x over cos x. So this is going to be sine squared x over cos squared x. And we are multiplying by 1 over tan squared x. A quick way of looking at this is we're saying 1 divided by tan squared x, which can be expressed as sine squared x over cos squared x. So we're going to use the rule of tip and times here. So this is 1 multiplied by cos squared x over sine squared x. And so you see how 1 times anything stays the same. So this simply just simplifies to cos squared x over sine squared x. And then minus 1. Okay, now there's no use of leaving it as minus 1 because the thing is, you have a minus, meaning these two terms need to add together. So for them to add, the denominators need to be the same. The denominator here is sine squared x. So we're going to change this to negative sine squared x over sine squared x. Okay, and now that is 1 expressed like that, and the denominators are the same. So this is equal to, and we have sine squared x over cos squared x, and we can add these two together now. Their denominators are the same, so they will be over the common denominator of sine squared x, and they are cos squared x minus sine squared x. Okay, that is a double angle identity. So remember this double angle identity. Okay, so it means that in place of cos squared x minus sine squared x, we can just say cos 2x, which you can see that we have in our solution. So this is simply sine squared x over cos squared x multiplied by, and that is cos 2x over sine squared x. And these two fractions are just multiplying. So since they're multiplying, whatever is common diagonally would cancel. Sine squared x cancels with sine squared x, and these are not common. So all we are left with as our solution is cos 2x over cos squared x. And that is our answer. And as we can see, that is indeed the right-hand side that we have. So it is finally equal to the right-hand side. And that is that identity solved. Question 5.3.2 says, for what value or values of x in the interval where x is an element of 0 degrees to 180 degrees is our expression undefined? Okay, so looking at this expression, for it to be undefined, then there are certain things that could happen. And it will depend on the denominator. So our denominator is tan squared x. And we're going to have to look at what tan squared x should be to make this expression undefined. So first, it would be when tan squared x is equal to 0. Now, where tan squared x is equal to 0 on the tan graph, that's where tan x is equal to 0. The tan graph looks like this. It first starts at a y value of 0 and then shoots up. And then we have an asymptote, and this is actually going to be an important point. An asymptote at 90 degrees, and then it comes from being close to the asymptote, and then it reaches 0. Okay, that's the y value. Now, so we can see that where tan x is equal to 0, the values of x for which is equal to 0 would be 0 and at 180 degrees. But here's what we need to look at, the domain. The domain says where x is greater than 0. Notice they use round brackets. So these are values that are greater than 0 degrees but less than 180 degrees. They're not equal to 0 or 180. They're just values immediately greater than 0 and immediately less than 180 degrees, and all through here. So despite the fact that tan 0 degrees is equal to 0, we're not going to include this because this is clearly not part of the domain they gave us. That's not part of the restriction. Okay, so we've considered that case. So in this case, this is where we have x is equal to 90 degrees. And that is that asymptote. The asymptote is where the graph is undefined. That's why the graph will never touch the asymptote. So we can see that that happens at 90 degrees. Okay, so our only x value for which this will be undefined is where x is equal to 90 degrees, depending on the restriction that they gave us. And that is our answer. Question 5.4 says, determine the general solution for the equation cos 2x equals cos x. Okay, so with this equation, you see that we've got a whole thing with cos going on here. So because this is cos x, and we know that cos 2x can also change to an identity with a cos x in it, but it would really be cos squared x. What we can do is go ahead and change cos 2x to this. Okay, now why we can introduce this is because you see that we have cos x, and then we have cos squared x, and we have minus 1. So this is going to create a trinomial. Okay, so let's expand it to that. We're going to change this to 2 cos squared x minus 1, and then we can transpose that cos x. So negative cos x is equal to 0. Okay, so writing it in that correct order, it's 2 cos squared x minus cos x, and then minus 1 is equal to 0. And this can be factorized. So we'll factorize this by saying what times what gives us 2 cos squared x, and that is 2 cos x times cos x. And then what times what gives us 1. Of course, it's going to be a negative 1, but 1 times 1 gives us 1. Okay, now to ensure that this stays negative, one of the ones needs to be negative. But we need to write it in a way that this middle term stays negative. So look at what happens. If you distribute, that becomes the 2 cos squared x we're looking at. And then this is going to be a 2 cos x. And when we multiply that, that is cos x. So which should get the negative so that this stays negative 2 cos x? We should give the negative to this, okay? And then if that's positive, negative 2 cos x plus cos x is equal to negative cos x. So that way, we need to give the negative to whatever created negative 2 cos x. We multiply this times this, and then we said 2 cos x times 1. So that's where the negative goes, and this stays positive. And there we go, we have factorized this. So this is equal to, we have 2 cos x plus 1 is equal to 0, or cos x minus 1 is equal to 0. And so if you transpose the 1, it's negative, and then divide both hand sides by 2, then we have that cos x is equal to negative 1 over 2. Or cos x is equal to positive 1. And now we just have to solve for x, find the general solution with these two equations. Okay, so regardless of whether you use the table, the Cartesian plane method, or a quicker method, or any other method, we'll still work with it like this. First, we need to get the reference angle. So the reference angle will be found by saying shift cos, or the second function of cos, and we take the absolute value of this. It's 1 over 2. So what does this give us on the calculator? That's going to give us 60 degrees. Okay, so we have a reference angle of 60 degrees over here. And now we can finally solve for x here. So we are solving for x, the angle in front of cos. So say that x is equal to, now remember that cos was negative. So the reductions using the table method, okay, the Cartesian plane method, the reductions where cos is negative would be in the second quadrant. This is in sine's quadrant, 180 degrees minus theta, and also in tan's quadrant, and this is the 180 degrees plus theta. So we'll say that x is equal to 180 degrees minus 60 degrees and then plus k of 360 degrees, or x is equal to 180 degrees plus 60 degrees, okay, using this reduction, and then plus k of 360 degrees. So x is therefore equal to, that is just going to be 120 degrees plus k of 360 degrees, or x is equal to 240 degrees plus k 360 degrees. And of course, this is where k is an element of integers. And that solves for this first equation. Okay, moving on to the second equation. The reference angle here, we need to find the reference angle as well. Where is cos x equal to 1? We know that cos x is equal to 1 at 0 degrees. Okay, that's the reference angle that we'll have there. So our reference angle is simply just equal to 0 degrees. And so this makes this really simple. Now, looking at where this is equal to, just looking at the graph, so that we don't have to find two unnecessary answers. With the cos graph looks like this, right? And so we know that, yes, at 0 degrees, this is where the cos graph has a y value of 1. Now, the thing about this answer is, because of where it is, it's at that maximum. It's going to repeat itself, of course, every 360 degrees, just like the sine graph does as well. So with this, it's going to be unnecessary for you to start saying, oh, x should be equal to 0 degrees plus k 360 degrees, and then still say, okay, the second solution for that would be where cos is positive, and then using this reduction on this. Because these are actually the exact same answers. If we had to say x is equal to 360 degrees minus 0 degrees plus k of 360 degrees, well, this is still 360 degrees minus 0, which is just 360 degrees plus k 360. Now, the thing with this answer is, it's like a replica of this one. Yes, this says 0, but think about it like this. If we're at 0 degrees, right, we're saying this is one solution that we're going to find here. This is a place where the y value of the cos graph will be equal to 1. But we already said plus k 360 degrees, meaning we are still accounting for the repeated solution every 360 degrees. See, this answer here will repeat itself 360 degrees later, and then 360 degrees later. But when you're looking at this solution, this is saying 360 degrees plus k 360. That's already this solution. It is just repetitive for you to repeat that again. So we don't have to say it twice. You can just leave one of those answers and you can omit or just cancel at that one. So we're really just saying here, x is simply equal to, you can say 0 degrees plus k 360 degrees, where k is an element of integers. And if you like, you can leave this as k 360 degrees, because we're just saying whatever integer value we put here, that will be the x value at which we will have a y value again of 1. Okay, that will be a solution. But it's fine to also leave it like that. Okay, so those are our solutions. If we have these 3 solutions, then it is fine. And that is it for this question. Question 5.5 says, given that sine theta equals 1 over 2, calculate the numerical value of sine 3 theta without using a calculator. Okay, so they've given us the value of sine theta. So why don't we express sine 3 theta in terms of theta? We try to separate the theta from sine 3 theta. And we can do that by expanding it like this. We can expand this to sine 2 theta plus theta. And they add up to 3 theta. And this is because with 2 theta, that's more familiar because of double angles. So we can always expand it to something that will have theta. And of course, it will still be able to get to a sine theta. So that's the whole point here, to relate everything to sine theta of some sort. Okay, so this is now in the form of the compound angle rule that we know, sine A plus B. So this gets expanded to sine 2 theta cos theta plus cos 2 theta sine theta. Okay, and then sine 2 theta, we can use double angles to expand that to 2 sine theta cos theta. Okay, so that's already looking good. We have a sine theta, but of course we'll still have to sort out this cos theta. Then it's multiplied by this cos theta over here, so we shouldn't forget that one. And then we have a plus 2 theta, rather expanded to something with sine theta. So we can expand this part to 1 minus 2 sine squared theta. But it's going to multiply by the sine theta, so it's best to write it as positive sine theta multiplied by all of this, since that becomes 2 terms. Okay, let's just simplify here. We're saying 2 sine theta, and then cos theta times cos theta is cos squared theta. We'll change that, and we can just distribute that. That is going to be sine theta and then minus 2 sine cubed theta. It's fine because it's still in terms of sine theta. We can still see a sine theta there. Okay, so this is equal to, and now we can focus on changing this. So this is cos squared theta. So we can change it to its identity with sine, okay, or sine squared theta, and that will change to 1 minus sine squared theta. And then we have plus sine theta minus 2 sine cubed theta. And lastly, now we can just distribute. So this is 2 sine theta when it multiplies to the 1, and when it multiplies to the negative sine squared theta, it becomes negative 2 sine cubed theta plus sine theta minus 2 sine cubed theta. And now we have like terms. So these two are like, as we can see, and these two are also like because they're both in terms of sine theta. So they simplify to, we have 3 sine theta, and then negative 2 minus 2 is negative 4, so sine cubed theta. And now we remember that they told us that sine theta is equal to a half. So in place of sine theta, let's substitute a half. So we're saying that sine theta equals 1 over 2. So this is 3 multiplied by 1 over 2 minus 4, and this is sine cubed theta. So it's multiplied by 1 over 2 all cubed. And we're just simplifying now. Okay, so these together give us 3 over 2. Now 1 over 2 cubed is 1 over 8. When you multiply this by negative 4, that's just negative 4 over 8, which simplifies to negative a half. 3 over 2 minus a half is 1. That's 2 over 2, 1. And so our final answer is 1. And that is the answer to that question. And that is it for question 5. Question 6 says, in the diagram below, the graph of f of x is equal to 2 cos x is drawn for the interval where x is an element of negative 180 degrees to 180 degrees. Also note that these are actual included x values. 6.1 says, on the grid below, draw the graph of g of x is equal to negative 2 cos x for where x is an element of still the same domain, and we need to clearly show all the intercepts with the axes and the turning points of the graph. Let's consider what the original cos graph looks like. The original cos graph, cos x, looks like this. If we were looking at it from 0 degrees to 360 degrees, it would simply create this shape. So it'll go up like this, then down, and then back up. And the highest it will reach would be 1, and the lowest would be negative 1. Now, with this graph, they have made this negative. But first, let's speak about this 2x. The 2x, the 2 in front of the x, is going to tamper with the period of the graph, okay, and how wide or narrow the graph looks. It completes a cycle. The original graph completes a cycle in 360 degrees, but this graph will now complete a cycle within half of this. So you always take the old period, the original period of that particular graph. The cos graph has a period of 360 degrees, and you divide it by the coefficient of x, which is 2. So it's going to complete a period in 180 degrees. So you see here where it should have been at 180 degrees and negative 1, it is going to complete one cycle in that. So this graph is going to look narrow. And then they add one more thing to this. So now this is cos 2x, right? They add one more thing by making this negative. So instead of it looking like this, all the y values are going to multiply by negative 1. So if this multiplies by negative 1, it's going to appear over here. 1 times negative 1 is negative 1. If 0 multiplies by negative 1, it stays the same. Now this one has a y value of negative 1 currently. If that y value gets multiplied by negative 1, it becomes positive 1. Okay, so you see that the graph is going to end up looking like this. That will still be 0, and that positive 1 will now be at negative 1. So it's just going to do this and then curve down like that. Okay, and the highest it will reach will be 1, and the lowest will be negative 1. Okay, now based on the angles that we have here, let's just figure out what we're going to have. Remember what it used to be before it looked like this. The y value of negative 1 will occur at 0 degrees. Then this y value of 0 will occur at not 90 degrees anymore, but half of 90 degrees, which would be at 45 degrees. And then this y value, which should have appeared at 180 degrees, is going to appear at 90 degrees. You see now that we're just moving in increments of 45 degrees. Okay, and 45 degrees later will be at 135 degrees. And then 45 degrees later will be at 180 degrees. Okay, so we now know what our graph is going to look like, and now we just need to plot it down. So at 0 degrees, we're going to have negative 1. At 45 degrees, it is 0. At 90 degrees, it is 1. At 135 degrees, it is 0. And then at 180 degrees, it is negative 1. So our graph is going to look like that. Okay, and it's going to do exactly what it's doing on this side, and it's going to do the same thing on this side, okay, because it repeats itself now every 180 degrees. So we're going to draw this same graph over here. Okay, so like that. So make sure to just point out these points, okay, the x-intercepts, the turning points, and any y-intercepts. Okay, and that is what our graph looks like. And that is the graph of G. Moving on to the next question. Question 6.3 says, write down the period of G, and so 2G and then x plus 10 degrees. So they are multiplying 2 to the graph of G, and in place of x, we're going to substitute x plus 10 degrees. Looking at our graph of G, it's the graph that has negative cos 2x. So with that graph, you already had a negative cos 2x. So if we're just multiplying a 2 to it, so it's going to become negative 2. And then in place of x, you're just replacing that with x plus 10 degrees. Okay, so at the end of the day, in front of the x when we distribute. This is just negative 2 cos and then 2x plus 20 degrees. In front of the x, it's still the 2 there. And that's what counts. That's what affects the period of the graph. So because there's still a 2 in front of the x, we're still going to say to find this period, we'll take the original period. Since this is a cos graph, the cos graph has a period of 360 degrees naturally. And then you just still divide by the coefficient of x, which is 2. So this is still 360 divided by 2, which is 180 degrees. So we can tell them 360 degrees divided by 2 is still 180 degrees. So it still has a period of 180 degrees. Moving on to the next question. Question 6.3 says, use the graphs to determine the value or values of x in the interval where x is an element of 0 degrees to 180 degrees, for which f of x multiplied by g of x is less than or equal to 0. Okay, so we need to specifically look within this interval. So we'll focus on that. So how can we ever get situations where the graph of f's y values multiplied by the graph of g's y values give us a value that is less than or equal to 0? Okay, so with equal to 0, if either of them are equal to 0, then this will work out. So we'll just keep that in mind. But with less than 0, the graph of f could have positive y values, while the graph of g has negative y values. And together when you multiply them, they will give you a negative value, a value less than 0. And then the graph of f could have negative y values, and the graph of g at the same time or for the same x values can have positive y values, and that way they would also give you a negative result. Okay, so they must either be positive and negative, never positive at the same time or negative at the same time. So let's look at that within this interval. So within 0 to 180 degrees, and that is all through here. And let's see where that is true. Okay, so looking at this section over here, where do we have the graph of f and the graph of g being of opposite signs? So we're referring to their y values. Looking at the graph of f right now here, its y values, you see that it has positive y values all through here. If you map these to the y-axis, that's a positive number and that's a positive number. So for the same x values, the graph of g should have negative y values. Okay, so I've also just put this here so we can also just keep track of that. So one of the ways that you can deal with this is by using a vertical line or your ruler. So you can scan through this just to see, because with the ruler, it's going to capture it for the same x value. Okay, you see, that's one single x value, and then the graph of f has a y value of that over there, whatever that is a value lower than 2, and the graph of g has that y value over there. So looking at it like that, when we scan through, you see that there, the graph of f has a positive y value, while the graph of g has a negative y value. That's the criteria we're looking for. They must be of opposite signs for the same x values. And as we keep going, there, that's positive and a negative. Keep going, positive y value, same x value, negative. But then once we reach this point over here at 45 degrees, you see that the graph of g is equal to 0. And we need that point as well. We can also accept when they are equal to 0. But then after this, the graph of g now has a positive y value. And for that same x value, the graph of f has a positive y value. That's not what we're looking for. We're not looking for where they're both positive. One needs to be positive, one needs to be negative. So in this situation, it's working all through here. So here until 45 degrees, okay, then it stops. So like that. That's positive and that's negative. And then if we take our ruler again and we keep moving, you see that here it's not working anymore. They're both positive. That's a positive y value and that has a positive y value. And we keep moving here, they're equal, both positive y values. And until we get to this point, you see that the graph of f has a y value of 0. Good, we want that. And the graph of g has a positive y value. So we'll take that. And as we keep moving, you see now that the graph of G has a positive y value, while the graph of f has a negative y value. And this keeps happening until we get to 135 degrees. At 135 degrees, the graph of G has a y value of 0 and the graph of f has a y value that is negative. And that is still working because 0 is also one of the requirements we're looking for. 0 times a negative whatever that is 0, and we want that, okay? It must be less than or equal to 0. They're products when we multiply them. And as we keep moving to the right, now you can see here that the graph of G has a negative y value, while the graph of f has a negative y value. It does not work there. Okay, that's a negative times a negative, which is a positive. We're not looking for that. So we can see that we have reached the end of where it works. Okay, so now we're going to highlight that last part. It worked all through here, okay, for both graphs. There we go. And then it stops at 135 degrees and doesn't go any further. So our answer, we're just going to answer them in terms of x. You see that here, it started working at 0 degrees and then it was values greater than 0. See, these are these x values over here, but less than 45 degrees, okay, less than or equal to 45 degrees. And then over here, it was the value equal to 90 degrees and then values greater than 90 degrees, but less than or equal to 135 degrees. So our answer will look like this. X is greater than or equal to 0 degrees, but less than or equal to 45 degrees, or x is greater than or equal to 90 degrees, but less than or equal to 135 degrees. And that is our answer. Okay, and of course we can also write these in interval notation, and that would be where x is an element of, we're going from 0 to 45 degrees, but remember that these are actual included values because x can be equal to 0 degrees and equal to 45 degrees. So we'll use square brackets here, and then we can say union, and here we'll say it's going from 90 degrees to 135 degrees, and we also use square brackets. So you can either write it like this or like that, and the answer would be fine. Moving on to the next question. Question 6.4 says, write down the maximum value of f of x minus g of x. Okay, so what is the largest distance between f and g? So let's look at our graphs. What we can also do here is use a vertical line. So we can draw a vertical line so that we can just see the biggest distance between f and g. So we're not looking at these parts because do you see that here? The graph of G is above the graph of F, like that, okay? So let's look at this part over here. From here, if we draw, and it's clear to see actually, it's that one there. If we draw a vertical line or use a ruler to just measure, you see that the biggest distance between F and G, because we're going to say the graph of F minus G, the y values of that, you see that the biggest distance happens in between here. And it happens at the graph of F's maximum and the graph of G's minimum. Okay, so you see that nowhere else does it have a larger distance between the graph of F and G. So this happens at 2 and then -1. So we'll just say the graph of F, meaning that y value of 2, minus this y value of -1, which is -1. So that is what it's going to be. We'll take f of x minus g of x, which is equal to 2 minus -1, and we can see that that is 3. So there we go. The largest or the maximum value of f of x minus g of x is equal to 3. And that is it for question 6.4. Question 6.5 says, determine the range of. The range refers to all the possible y values that a graph can have. So we don't really have to sketch this graph. We can just consider the expression. So since we have y equals 2 raised to the power of 2 cos x plus 2, how about we simplify that exponent? We can take out a common factor of 2 there. So 2 raised to the power of 2 multiplied by cos x plus 1. And this is y equals that becomes 4. So this is really just 4 raised to the power of cos x plus 1. So considering the range of this function, we don't have to think about it as a graph. We just have to think about it as what is the range? The range would be all the possible y values of this graph. So we would have to think about what the lowest y value would be and what the highest y value would be. So looking at the lowest and the highest of this, if we figured out what the lowest and the highest of this part was, we'd be able to figure out what the lowest and highest of this one is. So with the graph cos x plus 1, the lowest that this graph can go, because this is a cos graph, okay, naturally the cos graph, its lowest would be -1 and the highest would be 1. But this is plus 1, meaning this graph shifts 1 unit up. So instead of the minimum being at -1, it's now going to be at 0. And the maximum will be at 2. So now the lowest is 0 and the highest is 2. So this is what we're going to have to look at. If this cos graph in the exponent, its lowest it can go is 0 and the highest is 2, then this expression's lowest value would be 4 raised to the power of 0, since that is cos graph's minimum. So we're just taking what that graph's lowest is, and we're going to say 4 raised to the power of that lowest. So that's going to be 4 raised to the power of 0. That's going to be the minimum of that expression. And then 4 raised to the power of whatever the maximum of this cos graph is, which is 2. We can see that now. 4 raised to the power of 2, that would be the maximum. So we can see that 4 to the power of 0 is 1, 4 to the power of 2 is 16. This function will reach a lowest of 1 and a highest of 16. So its range is where y is greater than or equal to 1, but less than or equal to 16. And that is our answer. Okay, well, you can of course write that in interval notation, which is y is an element of, it's going from 1 to 16, and then we'll use square brackets because this is the range. These are actual y values that this expression can achieve. Okay, so that is our answer. You can either leave it like that or like this. And that is it for question 6. Question 7 says the diagram below shows 2 vertical poles, AD and BC. Point E lies on the same horizontal plane as the bases D and C of the poles AD and BC. And then they tell us these angles that we have. AB is equal to 2 alpha, BEC is alpha, ABE is 90 degrees minus 3 alpha, and BC is y meters. And the first question is to determine BE in terms of alpha and y. Okay, so in terms of alpha and y, since we're trying to find BE, you see that BE in terms of alpha and y would be using this triangle over here, BEC or BCE. So we can use, because this is a right angle triangle, we can use trig functions on this. So using alpha as our reference angle and using y because it's a side we actually have, and BE since it's the side that we are looking for. So you see that we are using the opposite and the hypotenuse. Opposite and hypotenuse means that we need to use sine, okay, in SOHCAHTOA. So this is sine of our reference angle alpha is equal to the opposite over the hypotenuse side. So that is BC, which is y, over our hypotenuse, which is BE. So over BE. And all we have to do here is make BE the subject of this formula. So if you cross multiply it, or you can actually just see it as transposing. Since this is in the denominator, when you transpose it, it will go to the numerator. So it's BE, and then we need this to move. It was originally in the numerator because it has a natural denominator of 1. When you transpose it, it's going to go to the denominator. So this is still y in the numerator over sine alpha in the denominator, and that is our answer. Question 7.2 says, show that AB is equal to 2y. Okay, so seeing that we just found BE to be y over sine alpha. Just remember that this has already been found. And now we need to show that AB equals 2y. Okay, so with that, we can use this triangle over here because it includes this side, BE, and it also has angles in them. And using this, because we're trying to find AB, we can use the sine rule. But with the sine rule, we're going to have the angle opposite that particular side we're looking for. And here we have that. That is 2 alpha. Now here we need to have a complete pair, a side available with expressed in terms of something, and then we need to also have the angle opposite it. So we have BE and we're going to use that angle. Okay, so we can actually find this angle since we have 2 other angles in this triangle. So this angle BAE is equal to, so let's go ahead and find that first. Angle BAE is equal to 180 degrees minus the other angles that we have there, which is 90 minus 3 alpha and 2 alpha. So we can say minus 2 alpha and then minus 90 degrees minus 3 alpha. So we're using brackets there because we had 2 terms here, so it has to apply to both. So that's 180 degrees minus 2 alpha minus 90 degrees, and then that becomes a plus 3 alpha. So this is equal to 3 alpha minus 2 alpha is alpha. 180 minus 90 is 90. So this is just 90 degrees plus alpha. Okay, so that is the angle BAE. And now that we have that angle, we can finally use the sine rule. So we're trying to find the side AB. So we're going to say the side over sine of the angle opposite it. The angle opposite AB is 2 alpha. So this is AB over sine 2 alpha. And this is equal to, we're taking another pair that is complete. This over here is now 2 alpha plus 90 degrees. And so this is simply just the side BE, which is y over sine alpha. And we're going to say over sine of this angle. Okay, so that is, so y over sine alpha. And we can just say divided by sine of that angle, 90 degrees plus alpha. Okay, now with that, you see that it has a denominator of 1. So we can just use tip and times over there. So long we'll just have AB over sine 2 alpha is equal to y over sine alpha, and that multiplies by 1 over all of that. Okay, so 1 times y still stays y, but the denominator is now going to be sine alpha times sine 90 degrees plus alpha, which is actually a cofunction. So this will simplify to cos alpha. Okay, and that's what we have. Then we can go ahead and transpose this since we need AB on its own. Okay, so AB is finally equal to, we're moving it from the denominator, so it goes to the numerator, and it is sine 2 alpha. But you see that we can use double angles to just expand that. So that's going to be times 2 sine alpha cos alpha, and this goes all over sine alpha cos alpha. And like that, what will happen is the sine alpha and sine alpha cancel, and the cos alpha and cos alpha cancel, and you're just left with 2 times y. So that is why AB is therefore equal to 2y. And that is our answer. Question 7.3 says, it is further given that AF is equal to 7 over BC, and they tell us to determine angle BAF, the angle of elevation of B from A, and we need to give our answer to the nearest degree. Okay, so it needs to be a whole number that we get as the final answer. Okay, so let's put that down. So AF is equal to 7 over 4 BC. So it's been named in terms of BC. AF is 7 over 4 BC. Okay, where is BC? BC is over here. which is y. Okay, so we'll just keep that in mind. That's just y. And then they told us to find this angle over here, BAF. Okay, so we are working with this right-angled triangle. And we have been told that this is the angle we need to find. We have been given this side. So this is the side adjacent it, okay, adjacent that angle. And we already have AB. With AB, that was 2y. Okay, so that makes perfect sense. Since this is 2y, they will both be in terms of y. So this is 2y. And since this AF is 7 over 4 BC, and we know that BC is y, let's just tell them what AF is. AF is simply equal to, since it's 7 over 4 BC, we're just going to put y there. So 7 over 4y. So they're both in terms of y. Therefore, we can just use this right angle triangle to find this angle. So in reference to this angle, this is the adjacent side. And this side that we have here is the hypotenuse because it's right opposite the right angle. So we'll be using adjacent and hypotenuse, meaning we're using cos. So let's say cos of this angle BAF is equal to, and we're saying the adjacent side, this, okay, 7 over 4y over 2y. And that's what we are going to work with. Okay, so cos of angle BAF equals 7 over 4y divided by 2y, which we already had. Okay, so y's would cancel, and this is really just 7 over 4 divided by 2, which you can say multiplied by 1 over 2. And so that is just equal to 7 over 8. So we're saying that cos of angle BAF equals 7 over 8. So to find this angle, you see that we're going to have to get rid of cos. So we can use the second function of cos, the inverse of cos on both hand sides. So therefore, we're saying that angle BAF is equal to, and we're just going to say shift cos on our calculator of 7 over 8 and find out what that gives us. So on the calculator, if you say shift cos 7 over 8, and we need to round off to the nearest degree, so the nearest whole number. So that 9 is going to round up, and that's going to add a 1 to the 8. So this is simply 29 degrees, and that is our answer. And that is it for question 7. Question 8 says, in the diagram below, the circle passes through points A, B, C, D, and G. And then they tell us that AD is the diameter of the circle, and then BD and AC intersect at H. And we are given one angle, which is AGC, and that is 58 degrees. The first question, 8.1, says, determine, given reasons, the size of the following angles. And we need to first find angle B2. Okay, so looking at angle B2, look at where it is. It's at the circumference, okay? And do you see that it's being supported by AD, which is a diameter? So the angle in a circle at the circumference supported by a diameter is 90 degrees. Okay, so that's angle in a semicircle. And we can go ahead and tell them that. So angle B2 is equal to 90 degrees. And this is because of angle in a semicircle. And that is our answer. Moving on to the next question. Question 8.1.2, we have to find angle B1. So we're going to mark down that this is 90 degrees. And if this is 90 degrees, how do we find angle B1? So B1 is also at the circumference. It's over here. Now, you can see that we don't really have any other angle that is supported by DC that actually has a numerical value right now, this arc. So we're going to go ahead and relate it to the angle that is next to it. Do you see how it sits next to 90 degrees? And together, if you join A, B, C, G, we have a cyclic chord. And we know that the opposite angles of a cyclic chord add up to 180 degrees. So we can just tell them that angle B1, so angle B1 plus angle B2 plus that angle that we already have, angle G, which is 58 degrees, that should add up to 180 degrees. And this is because of the opposite angles in a cyclic chord add up to 180 degrees. And we're trying to find angle B1. We know that angle B2 is 90 degrees and angle G, not G8, angle G is 58 degrees. So this is equal to 180 degrees. So we're going to add these two together. So that will be 148 degrees. So angle B1 is equal to 180 degrees minus 148 degrees. So that's really just 40 degrees minus 8 degrees, which is 32 degrees. Okay, so angle B1 is equal to 32 degrees. And that is our answer. The next question, 8.1.3, says we need to find the size of angle A2. So we know now that this is 32 degrees. And how do we find angle A2? Now, do you see that angle A2 is at the circumference and it's supported by this arc DC? But we also have another angle at the circumference supported by the same arc DC, and that's angle B1. So this means that angle A2 is equal to angle B1. So that's 32 degrees as well, because of angles in the same segment are equal. Okay, so we just tell them that angle A2 is equal to angle B1, and that is equal to 32 degrees. So therefore, angle A2 is equal to 32 degrees, and this is because of angles in the same segment are equal. And that is our answer. Question 8.2 says, if it is given that AB is equal to BC, prove that AB is a tangent to the circle passing through A, H, and D. Okay, so if it is given AB is equal to BC, we need to prove, given reasons, that this line AB is a tangent to the circle passing through A, H, and D. So we'll have a circle here. Okay, so it's something like this. You don't really need to draw that circle, or at least not that big. It's not necessary. Okay, and we're really just trying to prove that AB is a tangent to this circle. Okay, so using the tan chord theorem, we can tell them that angle A3, right, the angle between the supposed tangent and the chord in the circle AH, that it's going to be equal to the angle in this blue circle supported by that same chord AH. So the angle supported by that same chord would be this angle over here, and that's just angle D. We can call it angle D because there's no confusion with that. Okay, so that's what we are required to prove. We are required to prove that angle A3 is equal to angle D. And if we can show them that that is true, then this means that AB really is a tangent to this circle. Okay, now we have also been told that AB and BC are equal. Since they are equal, this creates an isosceles triangle. And so these two angles will also be equal. So angle A3 is actually also equal to angle C1. And because of that, we have the center angle. We can actually find their size. So let's go ahead and do that first. Okay, so we can go ahead and tell them that they are equal first. Angle A3 is equal to angle C1. And this is because of angles opposite equal sides are equal, not isosceles triangle really. And now since they are equal, we can add the angles inside this triangle. So we're saying that angle A3 plus angle C1 plus this entire angle give us 180 degrees. So that's angle A3 plus angle C1, and then we can just call this angle ABC. Okay, so we know that it's that angle ABC, that they give us 180 degrees, and this is because of the sum of the interior angles in a triangle. Okay, so adding these angles, we're saying that angle A3 plus angle C1, that they're exactly the same. So we'll just call them in terms of angle A3. So that's angle A3 plus angle A3, and that makes 2 angle A3, double of angle A3 plus angle ABC. Now that is 90 degrees plus 32 degrees, which is 122 degrees. Okay, so we know what that is, 122 degrees. And then now we can solve for angle A3. So if you transpose 122 degrees, that's 2 angle A3 being equal to 180 minus 122, which is 58 degrees. And then if you divide both hand sides by 2, angle A3 is therefore equal to 29 degrees. Okay, so that's angle A3. And now that we have angle A3, we also have angle C1, of course. Okay, to be honest, in this question, I really don't see the point of actually finding the numerical values of these angles. Because yes, we have angle A3 being 29 degrees, and that also makes angle C1 29 degrees. Then, if you look at this shape like this, in this circle that we already had, you can see that AB is supporting angle C1, and it's also supporting angle D at the circumference. So they will be exactly the same. So that's also equal to 29 degrees. So this is also 29 degrees. So we can just tell them angle D is equal to angle C1. So angle D equals angle C1, which is 29 degrees. And this is specifically because of angles in the same segment. And so the whole point of this is because we saw that the angle between this supposed tangent AB and this chord is 29 degrees, and the angle supported by that same chord in this circle is also 29 degrees, then that proves that this over here is indeed a tangent to the circle passing through A, H, and D. Okay, so at the end, we're just going to conclude that we can see they're exactly the same. So angle A3 actually is equal to angle D, and therefore it means we can just conclude that AB is a tangent passing through AH and D. Okay, AB is a tangent to the circle passing through AH and D. Now, we didn't use the tan chord theorem to prove this. We just showed them that the tan chord theorem is valid here. Okay, so we were able to show them that the angle between the tangent and that chord was equal to the angle supported by that same chord. Okay, that's the whole point of this. So the reason would be the converse of the tan chord theorem. And that is our answer. And that is it for question 8. Question 9.1 says, in the diagram below, O is the center of the circle. Points S, T, and R lie on the circle. QS is a tangent to the circle at S. And they want us to use the diagram above to prove that the angle between the tangent and the chord is equal to the angle in the alternate segment. That is, prove that angle QST is equal to angle R. Okay, so to prove this theorem, seeing that we are trying to focus on this angle and this angle, we are going to first draw a diameter. So it's going to go from S, O, and then extend to the circumference. So we can make it extend to a point, and we can call that P. And then we're going to connect these two together, okay? So P to R. And you need to ensure that you write down any constructions made. So we have drawn a diameter from S extended to P, and we are drawing line PR, joining those 2 points. Okay, and now to prove this theorem. With this theorem, it's one of the simplest circle theorems to prove. You need to really just focus on this. First, we're going to look at the fact that this is a radius. So the radius and the tangent are always perpendicular at their point of contact. So let's state that down first. We know that OS is perpendicular to QS, and this is because the tangent is perpendicular to the radius at their point of contact. But there's also another 90-degree angle that we have here, and that is this angle over here. Okay, because we drew a diameter, then the angle supported by the diameter at the circumference is equal to 90 degrees. So we can also tell them that this angle PRS is 90 degrees. So here you can conclude the angle that is equal to 90 degrees. In this case, we can just call this angle OSQ. Okay, so angle OSQ is equal to 90 degrees. This is just a conclusion from this. And then speaking about that at the circumference here, that is angle PRS. So angle PRS is equal to 90 degrees as well. But this is because of angle in a semicircle. Okay, now that they are both 90 degrees, here is the main point. You see how these lines run across, okay? So they're going to create angles in the same segment. So it means that this angle over here, angle PRT, is equal to this angle over here, angle PST. So these two angles are equal. And we can tell them that first. So let's tell them that angle PST is equal to angle PRT. And that is because of we have angles in the same segment. So since those angles are exactly the same, and we can see that this angle plus this angle needs to add up to 90 degrees, and so does this angle. So that would conclude that these two angles are the same. Since these two are already the same, and then they jointly have to add up to 90 degrees. It's kind of like seeing this as if this was 30 degrees, then this would also be 30 degrees. Now, since they have to add up to 90 degrees by default, that will have to be 60 degrees and 60 degrees. So since we have that fact, so here you can say, but we know that these two are equal, and so therefore by default, the other is also equal. So by default, it means that these two angles must be equal. So we can stick to QST because that's what they called it, is equal to this angle, angle R, okay, or really angle SRT, okay, and that is a conclusion. So that is really just angle QST is equal to angle R as they asked us to prove. And that is the proof of this theorem. Question 9.2 says, in the diagram below, D, E, and F are points on the circle centered at Q. AGF is a tangent to the circle at F, as we can see over there. ED is produced to meet the tangent at A. Then B and C are points on AE on this line such that GB is parallel to FD. GC is joined. And then they tell us that this shape over here, GCDF, is a cyclic quadrilateral. This shape over here that is not in the circle, but this is a cyclic quad. So we can use cyclic quad properties on this. Okay, so I'll highlight this shape. And the first question is to give reasons why angle E is equal to X. So let's see. Angle E is over here. Why is it equal to X? Okay, so we can see that we have an angle at the center, which is 2X, and it is also supported by chord FD. So that would be half the size of this angle. Okay, following the angle at the center is equal to twice the angle at the circumference supported by that same chord. So they ask for a reason, so we can just tell them that reason. Okay, so the angle at the center is twice the angle at the circumference supported by the same chord, and we can just tell them that that chord is FD. Okay, so that angle would be X. Moving on to the next question. Question 9.2.2 says, prove that GC is parallel to FE. Okay, so proving GC is parallel to FE. GC is this over here. And FE, okay, let's just keep in mind because you see that it's including one of the sides of this cyclic quad. We can use cyclic quad properties on this blue quad that we have here. So how do we prove that these two lines are parallel? Well, we can use fun angles. So with fun angles, we're looking at alternate angles. Okay, do we have any alternate angles here? From the way these two lines are, no, it's not going to create a Z. If it went like this and then this extended, then yeah, it would have alternate angles, but we don't. So we can leave that out of the question. Now, co-interior angles. With co-interior angles, I prefer to use these when I see numerical values. So for now, I'm just going to hold that off for now. And let's focus on corresponding angles. So do we see corresponding angles that we could work with and try to find out if those two angles are equal? Okay, so that would be these two angles over here. We can work with this and this. And the reason I'm working with those ones is because there's no confusion with what it is. This is angle E, this is angle C1. With this part, I would have to include like 3 angles over here. And so that may just be a little more complicated to prove. So remember that we already know that angle E is equal to X, so we can just put that down there. So all we have to do is find angle C1. And if angle C1 is equal to X, then we actually do have corresponding angles there, and it will make those two lines parallel. Okay, so looking at that, can we move from here to anything else? If you ever get lost, you can go back to your diagram and read the info that we have. Do you see that in the info they tell us that AGF is a tangent? So if this is a tangent, then it means that the angle between the tangent and this chord FD is equal to the angle at the circumference supported by that same chord. So if this is X, this is also X. And this helps us a lot because we know this is a cyclic chord. Okay, so we can start off over there. So we can tell them that angle F1 is equal to angle E, which is equal to X. And the reason they are equal, the reason it's equal to X is because of the tan chord theorem. And now that we got that equal to X, you can see that this is a cyclic chord. So we can use the exterior angle of a cyclic chord. The exterior angle of a cyclic chord is equal to the opposite interior angle. So that makes angle C1 also equal to X. So angle C1 is equal to angle F1, which is equal to X. So that is because of the exterior angle of a cyclic chord. Okay, and because of that, that proves that we were trying to just show them that angle E is equal to angle C1 because like this forms corresponding angles. There we go. Okay, so that would conclude that those two lines are indeed parallels. So we can tell them that angle E is actually equal to angle C1. And so because of that, it proves that GC is indeed parallel to FE. And that is because the corresponding angles are equal. Okay, and that is it for this question. Okay, with that, we can also just note down that these lines are now parallel. Okay, so this is parallel to this. Question 9.2.3 says, prove that AB over BD is equal to AC over CE. Okay, so let's see the lines they are referring to first. Just pinning that question to the screen so we can just see what they're referring to. AB over BD, so that's AB over BD, is directly going to be proportional to AG over GF. But they're saying that it's equal to AC over CE. So let's see where that is. AC over CE is over here. Okay, so it's because of those two parallel lines that we have. So let's look at it like this first. You see how AB over BD is equal to AG over GF because of the proportionality theorem, or we could also say line parallel to one side of the triangle. Okay, and then we'll put the reason down. Okay, because of the proportionality theorem. But we can also see, and now just to remove that confusion, we'll remove that. We can also see that AC over CD is also going to be, because of these two parallel lines, it's also going to be equal to AG over GF. For the same reason, but because of different lines. All in all, they're both equal to AG over GF. Okay, so I'll tell them, but we can see that AC over CE is also equal to AG over GF for the same reason, because of the proportionality theorem. Okay, so now that we know that, here's what we can conclude. Because they're both equal to the same thing, then they are also equal. So therefore, that concludes that AB over BD is indeed equal to AC over CE. And that is our answer. Then question 9.2.4, the last question for question 9 says, it is further given that AB is equal to 12 units, CE is 22.5. Okay, so they're giving us some lengths and ratios. So let's just fill in what we already had in here first. Let's just get that filled in first. Okay, so with this question, let's just put down what they have given us. Now, at this point, I'm going to remove this cyclic chord that I've pointed out here, because with what they're giving us the lengths of sides. That's not really going to affect whether this is a cyclic chord or not. The cyclic chord thing only affects the angles, okay, outside of it, and of course the opposite interior angle. Okay, so they told us first that AB is 12 units. So this is 12 units. We know that. And CE is 22.5 units. CE is 22.5 units. Now, they give us some information over here, and we're going to have to just simplify that. If they tell us that 5 AG is equal to 4 GF, then we can simplify this further by getting the letters on one side and leaving the numbers on the other side. So in order to do that, we'll divide both hand sides first and decide that we can keep the letters here. So divide both hand sides by GF so that GF is now on the left hand side. And then because we're going to have AG over GF, we don't want to have this 5 here. So we can get rid of the 5 by dividing both hand sides by 5 as well. So when we do this, then it means that AG over GF is simply equal to 4 over 5. Okay, so that's what we get from that. And the main goal of this is to determine the length of CD. Let's look at this and just formulate a way to find CD. But let's just put down what we have here. AG over GF is 4 over 5. Okay, and we also already proved in the previous question that, that was also equal to AG over GF and that as well. So we'll also keep that in mind. So AG over GF is 4 over 5. So we can call AG, we can call that 4A. Okay, so that is just to show that it's not the length, it's just a ratio. So whatever this line's length is, AG just takes 4 parts and GF takes 5 parts. So we'll say that is 5A. And this is what we have right now. Okay, so how can we use this information to find the length of CD? Let us construct a way to find CD. So here's the plan. We're trying to find CD. And to find CD, because it's this line over here, I wanted to use this side, but I'm not too confident about this side because I could have said, okay, why don't we just say CE since we have that minus DE? But now finding DE and trying to relate it to something, that seems like something that may be a headache. So I'm going to avoid that. Let's not go with DE. We can look at CD on this side and now it has more familiar looking sides. Here's what I mean by that. CD can be found by taking the entire length of AD, okay, like we have over there. And if you subtract this by AC, then that gives you CD, okay? So that is our plan. And the reason I'm saying this option looks like it would work more is because since we are taking AD, notice how AD is actually part of a triangle that we are working with. It's part of a triangle that has 2 parallel sides. And we can just highlight this. It's part of this triangle, AFD, okay, that triangle. And AD is that side. So it means that we can actually find the length of it if we know the ratios. And we do know the ratios. We know that AB over BD is, and we can actually just put that down now. So AB is 4, but we cannot call it 4A since this one is called A. So we'll call it 4B. So AB is 4B and then BC would be 5B. We're just using the proportionality theorem here, okay, because they were proportional to AG over GF. So here we should just find this. We should just ensure that we find AD and AC. It's always good for you to put down your plan so that you don't get distracted and you only focus on the things you actually have to find. Okay, now focusing on finding AD, let's see. Let's just see the triangle that AD is a part of, okay? Since we know that it's part of this triangle and this is the line that is parallel to one side of that triangle, then using the proportionality theorem, which we've already used previously, we can just find out what AD is, okay, straight away. Because the thing is, we have one length in this, and we'll just leave this in blue actually. So we have one length, which is AB, and this is more than enough to help us to find AD. So here's how we can rewrite this. We can tell them that AD over, And so we're taking AD. Now you'd have to take it over a side that you actually have in this triangle. So in this blue triangle, the only other side we have is this. That is 12 units, AB. So we're going to take it as AD over AB. So this would be equal to, using the proportionality theorem, if you take AD, you have to take AF. So AF over, and then we took AB, so you have to take AG. So that's AG. Okay, and this is because of the proportionality theorem. Okay, so now we can conclude. We're trying to find the length of AD. So AD over AB, which we have as 12 units. So AB over 12 is equal to AF over AG. So AF, that entire ratio would be 9, 4 plus 5. So 9A over 4A. But you don't have to write the A's because we're already writing them over each other. So they are ratios in this case. So that's 9 over 4. And then straight away we can find AD. If you multiply both hand sides by 12, AD is therefore equal to, so you can show them that you multiplied by 12. Here 4 would cancel, so you'll be left with 3. 9 times 3 is 27. So this is 27 units, and we've found AD. Since AD is 27 units, we have found AD, and now we can focus on finding AC. Okay, so let's just highlight the triangle that AC is part of. Now, AC is part of this triangle, and there it is over here. So we can also find its length. Since we have one of the sides on this line, we have CE. So we can say AC over CE is equal to AG over GF. And this is because of the proportionality theorem, but you see that we've already proven this in the previous question. So we can just use this idea here, and we're saying AC over CE. Now we know what CE is. They told us that CE is 22.5. So 22.5 is equal to AG over GF, and we know those ratios. AG is 4 and GF is 5. So we can say this is just equal to 4 over 5. Okay, and then at this point, we can solve for AC by multiplying both hand sides of this equation by 22.5 to get it out of the denominator. So let's see what we get for AC. And AC is equal to 18 units. Okay, so now that we have AC, we can finally find CD. So we're using this equation that CD is equal to AD minus AC. So this is 27 minus 18, which is 9 units. And there we go. CD is equal to 9 units. And that is the answer to this question. Question 10 says, in the diagram below, K, H, and G are points on the circle, and FG is a tangent to the circle with the center E. So that's all in relation to this circle over here. Then they tell us that a semicircle with center F is drawn. Points D and E lie on the semicircle. CD and CE are tangents to the semicircle at D and E respectively. And lastly, CD is parallel to HE. And the first question asks us to give a reason why DC is equal to EC. Okay, so why is this line equal to this line? Well, they told us that those two lines were tangents. If they're tangents to the semicircle, then tangents drawn from the same point are equal. So we can just put down that they are equal so we can follow that. Okay, so that's our reason. Tangents drawn from the same point are equal. Question 10.2 says, prove that triangle DCE is similar to triangle HEK. So let's highlight those triangles first. Triangle DCE is this triangle here, and then HEK is this triangle over here. Okay, and we need to determine why these are similar. So we can focus on all their corresponding angles being equal. Okay, let's figure this out first. So do you see that we have parallel lines? Okay, CD is parallel to HE. So we have alternate angles. So it means that this angle, angle C, is actually equal to angle E2. So we've got two angles in both triangles being equal first. So now that we know that these two angles are equal, here's another thing. This is an isosceles triangle, but so is this. This is also an isosceles triangle because do you see that EH is a radius and EK is also a radius? So that would mean that they both have these two angles of theirs being equal. So this one will have these two being equal. If these are exactly the same, for example, let's say this was 80 degrees, then this by default has to be 50 degrees, and that's 50 degrees. So if these two were equal, then this would also be 80 degrees. And then you see by default, that would also be 50 degrees and 50 degrees. Okay, so them having an equal angle and then being an isosceles triangle makes their angles all equal. So their corresponding angles are equal. So that's what we're going to go with. Okay, let's introduce our triangles. So we're just going to say in triangle DCE and triangle HEK. And here's what we are listing about them. So we know that angle C is equal to angle E2 because of alternate angles. So angle C equals angle E2 because we had alt angles. And here you just have to state the lines that were parallel that helped to find these alternate angles. So that is CD was parallel to EH. You can say it the same way they did. Okay, so because of those parallel lines, and then you see that we had isosceles triangles. Both of them were isosceles. So we can just first tell them that CD is equal to CE. And this was proven in the previous question, so I'll just say proven. And because they're equal, that means their base angles would also be equal. So therefore, angle D is equal to angle E1. Okay? And then in the other triangle, in this triangle, we can see that EH is equal to EK because that is a radius and that's another radius. So because of equal radii, okay, and we can tell them radii. And so therefore, the angles that will be equal here would be angle K1 is equal to angle H. So we can conclude angle K1 is equal to angle H. Now in both of these, right, when you conclude that those angles are equal, those bottom angles here, it's because we have angles opposite equal sides that are equal. So that reason needs to be stated here as well. Okay, and now finally to conclude that these angles are equal. Okay, if you get these two to be equal, then these two are also equal. So to do this, we can use the sum of the angles in this triangle. So if we are adding the angles in the red triangle, we'll say angle C plus angle D plus angle E1. Now we can focus on angle D being the angle that we'll leave. Remember that these two angles are already equal, so we're going to say that this is actually angle C plus double angle D, and that is equal to 180 degrees. And then we'll make this the subject, and we'll show that they're actually exactly the same. Okay, so we can go ahead and show them this. Because we already showed them that that was equal, we can say that angle C plus 2 angle D is equal to 180 degrees, and this is because of the sum of angles in a triangle. So therefore, 2 angle D is equal to 180 degrees minus angle C. And then just to make angle D the subject, we can just divide both hand sides by 2. So this would mean that we're saying angle D is equal to 180 degrees minus angle C over 2. The whole point is that the equations are going to be exactly the same. So that's for the red triangle. Now we're going to do the same for the blue triangle. Using the sum of the interior angles in this triangle, we're saying that angle E2 plus angle K1 plus angle H is equal to 180 degrees. So I'm going to leave angle H as the one we'll keep. So this means that angle E2 plus K1 and H are the same thing. So we'll say 2 angle H is equal to 180 degrees. And again, this is because of the sum of angles in a triangle. And then we can make angle H the subject. So 2 angle H is equal to 180 degrees minus angle E2. And so therefore angle H is equal to, if we divide both hand sides by 2, it's 180 degrees minus angle E2 over 2. Now, here's the thing. The reason we are saying or trying to prove that these two angles are actually the same is because we already proved that angle C was equal to angle E2. So that means that represents the exact same thing over there. So we can tell them, but we already know that angle C is equal to angle E2. So what this will prove is that if you take angle C and you replace it here, you see that they're going to say the exact same thing. Angle D and angle H are the exact same thing. So that concludes that angle D is actually equal to angle H. So you've got two angles equal in those triangles, angle D and angle H. So this is actually equal to this. So we can just conclude that means that angle K1 and angle E1 are also equal. Okay, and that covers the three angles in each of these triangles. So it's the angle C and angle E2. So these two angles first. We have shown them now that angle D is equal to angle H. Okay, so we've proven that over here. And we have shown the last two angles in those triangles. And there we go. Because of those, then these triangles are similar and we can finally conclude this. So therefore, triangle DCE is similar to triangle HEK because of angle, angle, angle. And that is our answer. Moving on to the next question. Question 10.3 says, prove that DG is equal to GE. Well, do you remember that they spoke about FG being a tangent? They said FG is a tangent to the circle with the center E. So if this is a tangent to this circle, and we can just erase these for now, they may not be that important. So if this is a tangent to this circle, right? And you can see that this circle has a center at E. Okay, so since it has a center at E, then it makes this a radius. So EG is a radius and FG is a tangent. The radius and the tangent are perpendicular at their point of contact. And here's how this helps us. You see that in the semicircle, we have F being the center. If F is the center of the semicircle, then this is a line from the center of the circle perpendicular to the chord. And what does that line do to that chord? DE, it's going to bisect the chord. And so that's why they will be equal. Okay, so we can start off by telling them that EG is perpendicular to FG because the tangent is always perpendicular to the radius at the point of contact. And this is because of the tangent being perpendicular to the radius. And now that we have that being 90 degrees, we can just tell them that DG is equal to GE because of the line from the center of the circle perpendicular to the chord bisects the chord. Okay, so that's just our conclusion. DG is finally equal to GE, and then we'll put our reason. And there we go. That is our answer to 10.3. Question 10.4 says, show that 2HE squared is equal to DC multiplied by HK. Okay, so I'm going to pin this to the screen and let's look at the diagram. Okay, so with this question, let's go ahead and highlight the lines they're referring to. So they want us to prove that 2HE squared. So HE, meaning HE may have been used twice, but then again, we have a 2 there, but we'll see. So we're looking at HE, DC, and HK. And let's just see where these are from. So they just look like they're part of this triangle, which we found were similar. So let's see how they came about with that. They're using this side, HK and HE. And that goes with this side, DC. But then it wouldn't make sense for them to not use another side in this bigger triangle. Because for you to use their proportions, okay, as they are similar, you would need two sides. Okay, so we need to figure that out. Okay, so looking at this for a while, I found that it was strange that they included 2. So this 2 definitely came from somewhere. And then this is HE squared. So HE was used more than once. And here's the thing. If you look at this triangle, this one over here, HE is a radius, meaning EK is also a radius, right? Now, because you have these two radii, you will also notice that you have a third radii, and that's from E to G. So they used this side DE clearly because they used DG and GE. But instead of using it as GE, they said because it's equal to HE, we're just going to call it HE. Okay, so here's the thing. We know now that they use these two. Okay, so it's this and this side, and then this and this side. Okay, so let's go ahead and just get this from their proportions. We need to always make sure that we use them in order. That's why it's important to name it correctly. Normally, they tell you which triangles to prove are similar, so they already name it for you. So it's best to stick with that naming, the way they named it. Okay, so looking at that, we know now that they were similar. And now we need to ensure that we take the sides mentioned or the sides that are highlighted here, because we can clearly see which sides they were using now. Okay, so this is actually going to get to the answer because we can see it includes everything that they gave us, they asked for, and everything in this triangle. So we can go ahead and tell them that we're taking DC. So if you take DC, you need to take it over. So we're taking the first and second letter. It needs to go the first and second letter as well. So DC goes over HE and it's equal to, now the other side they used in this big triangle was DE. So if you're taking DE, that's the first and third letter, you need to pair that with H and K. So HK. Okay, so this is what we're using. Okay, and the reason for this, the reason we are able to use this is because we had similar triangles. So we can just tell them because we had similar triangles. Okay, and now with this, we're going to have to make it look like this. So we will have to show them that relationship with DE. So let's go for that. That line DE, okay, let's start here by GE. We know now that HE is a radius, but so is GE. It's also a radius, so they are equal. Okay, so HE equals GE because these are equal radii. And since they are equal, now we can just make that relation with DE. So this means that DG would also be called HE since it's already equal to GE. So we could just say, but we know that DG is equal to GE. So because they're both equal to GE, then DG is also equal to HE. And now let's tell them where that bigger line DE comes from or what it is made up of. DE is made up of DG added with GE, which we know are both HE. Okay, so GE. And let's put that down. And so therefore, this means that DE is actually, because they're both equal to HE, that is HE plus HE, which is 2HE. Okay, so now we know what that is. And now we are going to go ahead and use this proportion because that's really what they used. That was the whole point. As you can see, it includes DC, HK, HE, and then we see where the DE came from. It was just this. So we're going to rewrite this again. And now in place of DE, we'll substitute 2HE. So therefore, this means that you don't even have to rewrite that. You can just say, therefore, this is DC over HE is equal to 2HE over HK. And now just to put it in their formats, you see that they got this to be on its own. So let's go ahead and cross multiply first. If we cross multiply, then this is HE times 2HE. So 2HE squared is equal to DC multiplied by HK, just like they have it. Okay, so that is our answer. Okay, and there we go. So that is our answer. And that is it for the Euclidean geometry section of this paper. And that is it for this paper. Okay, so that is the last question. And that is it for this paper. I hope you guys enjoyed it. And I will see you guys in the future videos.